Good morning to participants. Uh, Yesterday we have completed the two sessions and two article discussions. So today we will start the sessions. That is today's research person is Dr.L Sastry Garu. Let me introduce the L Sastry Garu. Sir, please. Today's research person L Sastry Garu. So we have two sessions and two article discussions. So let me first Triple HOD, Rajni Madam. Madam, please today's session, please some few words about this today's workshop. Faculty day.
Good morning, dear participants. So today's resource person is Dr.L from NIT AP. So all of you utilize this session and learn about the current technologies on PV systems which are integrated to electric vehicles, and also and learn about the current trends, and you can teach your students so that they can learn about the current technologies. Thank you.
So thank you, madam. Today we'll see the 5 minutes. So some participants have some doubts about how to write a research article submission. So I will show you yesterday's two article discussions. After that, so the first session, that is today's session, will start. So please open that video. Okay, so all of you see the article discussion. So the first you have to write the faculty development program dates. So after that, write your name. So the next one is your institution name. Okay, your college name. So after that, the paper, research paper, the first research paper. So after that, you have to write in your own words. You have to write the report number one, because we have discussed the two articles. So in the article session, that is at 12 p.m. You have to mention time also, 12 p.m. to 1 p.m. So then whatever you have understood, okay, so those points you have to write in the document. Then you have to make a PDF. So the name should be your in the list we have given. Okay, roll number 1, 2, 3, like that. So it is better to save like that, so that you can download the papers easily. So that is the thing. So the next one is whatever you have understood. So the like that you have to submit the article number one and number two. Okay, so at the end you have to mention so how these agri-PV systems are useful for society also. So this about the so you have to give some examples also. So that is other than India, what are the agri-PV systems installations like that. So that is article research number one. So that similarly you have discussed the article number two. So the similar format you have to write here. So the same format. So that is first you have to write Atal faculty development program. You have to mention dates. After that your name. So because this is submitted by Sarvan sir, that is Mother Teresa Institute of Technology, submitted by the sir. So if you have any doubt, please get the information from the sir. So that is the same similar fashion you have to write, that is the institute name. So the next one is the session, the last second article discussion. So the time 4 p.m. to 5 p.m. like that. So you have to write so the key points. Then what are the important how these agri-activities are used for society like that. So like that you have to submit by 6 p.m. because the sessions are going from scheduled from so the 9 a.m. to 5 p.m. So it is very difficult to get time. So that's why you have to do after 5 o'clock. So thank you very much for attending this faculty development program. So now today's session will start. So the sir will take the sessions. So the first session starts now. Sir.
Good morning, one and all. This is PL1 SASTRY. Today, the discussion was on impact of agricultural PV systems on farm productivity and sustainability. Before going to this, why the PV is needed for agriculture needs? Most of the cases in our agricultural fields, we use motors, pumps, heaters, ventilation purposes, air flowing, and then dryers. All these are by using conventional fuel mechanisms like kerosene and gas and some of the conventional fuel mechanisms we are using. The major drawback of conventional fuel system is by using this conventional fuels, kerosene, diesel, propane. Propane is a gas for different operations like various pump systems and various motor operations. All these are used by using conventional fuels. For this, the major drawback is these are the major drawbacks. Transportation is very difficult because the generator location is far away where the paddy field is available. In that paddy field itself, the generator will be available or a pump will be available. For that pump, near to that pump, there is a no fuel station will be available, and all the paddy fields will be located at a remote place which are outside the city or outskirts of the city, so that the transportation of various fuels like petrol, kerosene, diesel, and gas into that particular location is very difficult because of the different challenges of roads and landscapes. And due to this transportation process, there are some those spills will be available. The fuels will be spilled out, and it causes the contamination of the land while moving on to a paddy field. If the fuel, whether a petrol or a kerosene, is spilled out and spread into a paddy field, that is another additional uh, drawback for the paddy field, which will contaminate the complete land and the paddy field which are already available in that particular the crop which is available in the paddy field. That is one major disadvantage by using conventional fuels. And fuel cost is also increasing because of if I want to use 1 liter of petrol for a particular 1 acre of land, I transported 1 liter of petrol from distance or far away to a paddy field, but at the end, while reaching to that particular paddy field, I got only half liter. That based on that spills, this cost will also increase. This is an additional cost burden for the farmers due to the conventional fuels. And there are different additional to this fuel cost, we have different mechanical parts will be available for generators, pumps, wear and tear will be available, aging effects will be there. For each and every motors, there will be some mechanical parts. For those mechanical parts, the regular maintenance of those mechanical parts will be needed. That is an additional burden. Along with this particular replacement of mechanical parts, the fuel will be the more fuel cost will be the additional burden to the farmer. And there are some cases where the based on the due to the spills of different fuels, there may be a fumes available in that particular livestock, and there will be some noises available. And due to the use of petrol, kerosene, diesel, there are carbon dioxide emissions, carbon monoxide emissions. These are also affecting environment and the paddy field. this is also an additional burden to the farmer to increase the yield or to increase the productivity of that particular paddy field. These are the major disadvantages or drawbacks of a conventional fuels. To avoid this conventional fuel disadvantages, we move on to a renewable energy sources rather than using fossil fuels or a conventional fuels in a agriculture scenario, like renewable energies like solar, wind, and other renewable cases. Our major aim in this FDP is integration of solar onto agriculture, so that I concentrate on solar based systems for agriculture. And I mentioned all the basic disadvantages of each and every cases for propane and bottled gas due to the there will be a disadvantage of this rather than normal kerosene or fuel. There is another disadvantage of this propane or bottled gas. Due to this bottled gas transportation, the transportation cost is very high, and there is no safety for that propane gas to be transported from a particular gas filling station to a remote location of a paddy field where the paddy fields and the generators will be available. That is a major drawback for using bottled gas or propane gas. For all these situations, the only alternative is solar energy. In the case of solar energy, we cannot able to, we don't have any transportation cost, because in the paddy field itself, sun is available everywhere. So that the sun, based on the sun illumination or irradiation of sun, the sun irradiation will be converted into electrical energy. That electrical energy is used for motors, pumps, and heaters, dryers, and all for a paddy fields. Okay, in that case, we can directly generate or provide energy which is wherever needed and whenever it is needed. Whatever the case it is, when the motor is on, then directly the stored energy which is available in the battery, which is stored due to the morning session or the morning time while sun is shining, and that will be useful for a motor and pumps to be operated at different time spans of the day, whenever it is needed and wherever it is needed, whatever may be the remote location it is, we can install solar panels because sun is available at anywhere. Okay, this is the major disadvantage of solar energy systems which are applied to agri-tech for agricultural productivity. There are two types of solar. One is direct solar energy is directly converted into DC value, DC energy. That is conversion of solar energy to a DC power. And another case is conversion of solar energy to a heat. In agricultural settings, there are different cases where we use DC energy or AC energy based on the motors and pumps which are used in your agricultural fields. We use electrical energy either in DC form, that is direct current form, or a AC form based on the pumps and motors which is available, AC motors or DC motors. In those cases, we use the solar energy which is directly converted to a DC power, whereas in some cases where we have a heaters, dryers, and temperature monitoring systems, where some of the greenhouse paddy fields, we need some temperature always to be maintained for some of the crops. In those situations, we use the solar heater, that is the solar energy directly converted to a heat energy that will be transformed by using a basic convention process. That solar energy will be converted to a heat, and that heat will be transferred to a complete livestock, or this will be connected to through pipes. That is also possible in the case of these two scenarios for agri-tech. is converted into a electrical energy in case of photovoltaic systems. The basic thing of solar energy first, based on the solar cells in the which are available in the PV module. We have a PV module. For a PV module, we have different solar cells which are arranged in series and parallel connections. Based on that, the electrons which are striked and the light energy is converted into a electrical energy by bombarding different electrons inside the solar cell. So that the electrons will be moving. That electron movement is taken as a electrical energy that will be taken as a captured as a DC form, and there will be a DC battery which is stored this power which is available at the output of a solar panel that will be stored into a battery. Further, this electricity which is stored into a battery is used for different applications like connecting a particular load, and water pump is a better load in an agricultural system. Like this DC energy will be stored in the case of a battery. That is another scenario where energy storage is needed. This energy storage, we have batteries are the main primary energy sources or energy storage devices. In some cases, we use capacitors are also having capacitors are also installed as a storage devices for storing of DC energy for a less time period. In this case, I would like to discuss for a battery case. In the case of batteries, the solar energy is available only when sun is shining. So that the solar is not available. If I want to use solar energy for agri-tech, solar is not available during 24 hours of a day, but it will be useful mostly 10 hours a day, morning 7:30 to evening 5, like that. At that time, that energy will be captured from the solar modules which are available. The solar modules which is placed on a sunshine, and the energy which is captured in the morning time, that is sun shining time, and that will be stored into a battery. That will be used for other applications where the night time applications. Most of the cases, the watering system and pumps, water pumps and solar agri-tech pumps will be operated in the evening times, that is on off-peak load in grid scenarios. In those situations, the energy is not available based on the solar case. Energy is not available at the night time, so that will be stored into a battery, and that will be used for night purpose, night operations at the night. And this is a cost-effective solution when compared to a normal PV system. The solar energy-based operation of a agri-tech or operation of different motors in an agri-tech will be a cost-effective solution, and it is also economical because at any remote place we can install solar. That is a major advantage of solar PV into agri-tech. And most of the cases, the general grid cases, if I want to use a grid power or a normal generated power by the transco, that will be very difficult to distribute from a generation station to a remote location paddy field. That is a big drawback of using conventional energy when compared to solar energy. Here, this solar energy will be, these PV systems are most cheaper when compared to the transforming of various energy scenarios, because the generation is of a higher level that will be transformed or distributed to a particular paddy field. Again, that high level energy, that is 132 kV or 11 kV, will be again stepped down by using another step down transformers. Again, that will be again stepped down to a three-phase system or single phase system based on our utility, that is single phase motors or three phase motors which are used for a agricultural needs. In those situations, this is a more costlier process of stepping down of different power values by using a transformer when compared to a PV system. Where PV system directly we use a number of solar panels based on our requirement. If I want a 12 volts DC energy, I use based on a 12 volts energy. I use only one panel or two panel, which will generate a 12 volt energy, and it will be stored into a battery. And again, this will be useful for different applications like water pumping system, fencing, solar fencing will be there, electric fencing, and then building lighting inside a crop. There will be a livestock will be available. In that case, we are having building lighting will be available, and then there are some livestock watering cases and drip irrigation cases. We use crop irrigation supplies also by using this solar cases. This is the motivation of various solar-based systems, and how the solar-based systems is useful for agriculture when compared to a normal fuels and conventional fuels. Normal rather than normal fuel, it is a conventional fuels. Another application of solar is water pumping system, because solar is not useful in the previous case. We use energy case. This is an energy case. Solar is used available at the sun shining scenario, and that will be captured. Solar energy will be captured in the daytime, and it will be stored into a battery as an energy, DC energy, and it will be used for a further purposes. By in the case of energy, where another situation in a agricultural system is water pumping. Most of the cases for a paddy field or any fields, crop irrigations, we use water as a primary source of energy, and that water will be pumped from a submersible pumps or any wells which are nearby to that particular crop or a paddy fields. In those situations, we use solar panels in the daytime. By capturing the energy of a solar panel, we pump this water and store this water into a overhead tanks, which is useful for a further purposes, which when and where it is needed. Then this high kinetic energy water storage system will be useful by using a kinetic energy rather than any electrical energy. Electrical energy, by using electrical energy, we pump the water and again feed to a crop. Rather than that, we store that we store that water, complete water, which is pumped in the daytime where the solar is available, and stored in the water tanks that is available in a high kinetic energy, that will be again useful for further purposes in the aggregate. That's what I given here. We can by using this process, by storing the energy or storing the water or stocking a particular water for irrigation purposes, we eliminate the need of batteries, and simplicity will be increased, and overall system cost will also be increased, because we don't have any electrical energy used for a pumping purposes. We directly use renewable energy in the morning time and store the water in a overhead tanks and use for a crop irrigation purposes. And these are the other uses: lighting of agriculture buildings and different electrical appliances like electric fans for circulation of water. There are different greenhouse crops will be available, which will be growing in a housing, in a livestock manner. In a livestock manner, having different chambers. Those chambers will be maintained. If I have three chambers which are connected together, one crop type will be having more temperature scenarios. In some other crop case, they need lesser temperature values. In those situations, that air circulation. Hot air and cold air will be circulated into a livestock chambers by circulating that livestock what by circulating that air, hot air or cold air, we are maintaining the irrigation process. Productivity is also increasing in those situations. Like this, we are using dryers. Another situation, we see pumping and electrical energy uses, and third case is dryer case. Dryer case, which I already discussed. We are using a solar rooftop in a livestock. This is my livestock room. For this livestock room, I am using a solar rooftop. By using a solar energy, this will be solar energy will be absorbed, and it will be converting. The solar energy is converting based on the requirement of this particular livestock chamber, whether it may be a cool air or a hot air, will be flowing into this particular chamber, where the feed will be the agri feed will be available in this particular livestock. Okay. There is another essential case in agriculture. In this crop drying scenarios, there are some dryers based. In the general scenarios, we use all the seeds like paddy seeds or paddy grains will be left over the sun in olden days, because sun is the primary source of energy. By using that sun primary energy, there are some disadvantages. Heating of sun, simply exposing the grains to the heat of the sun. This is the oldest method. For this, there are some disadvantages, which is contamination of that particular grains with some insect contamination, and there are some birds. Birds will be available, and birds will spoil your grains when you are leaving the grains into a sun atmosphere. For that purposes, we are more concentrated on solar-based dryers for crops which are having which want heat air, and most of the cases we dried the grains on solar dryers itself. This is one case where solar energy is collected, and the collected solar energy will be directly converted into a heat air. That heat air will be by using a natural convection mechanism, or by using a fans or any tubes, we are supplying the hot air to a crop or a paddy field grains for dryer purposes. These are the major scenarios where the solar is used for different agricultural based scenarios. This is another case, solar water heating system. In some cases, we need hot water for cleaning of livestock. Let us suppose for a piggeries or poultries. For those situations, we need to clean the complete poultries and piggeries with hot air for contamination of insects, for avoiding contamination of insects. In those situations also we need energy, electrical energy. By avoiding that electrical energy, we are using a renewable energy, which is a solar, mostly solar case. By using that solar, we convert that solar energy into a heating mechanism, and solar uh, water heater is used to convert the solar energy into a hot water. And based on this hot water, we are cleaning these livestock like piggeries and poultries. Poultry pen and equipments in the poultries, we are cleaning periodically by using water heaters, and these are very commercial, commercially available water heaters, and these are the installation is very simple for solar heaters also.
Sir, I have one question.
Tell me.
Is government is giving any subsidy for water pumping system or
For all the solar needs, government is giving subsidies. Presently, already one scheme is available, sir, for solar based. If you want to install a solar, government is providing for 1 kilowatt, up to 1 kilowatt solar panels. If you want to install in a that is Surya Yojana. Huh? Algar Solar Yojana. Okay. Hargar Solar Yojana. Previously it is Surya, that is renamed as Hargar Solar. If you want to install for 1 kilowatt, they are given a subsidy of 30,000 up to 1 kilowatt. Beyond 1 kilowatt, up to 3 kilowatt, they given a subsidy of 78,000 of the complete installed cost. It generally costs up to 1.5 lakh. Among that 1.5 lakh, government is subsidizing 78,000 on the installation purposes.
they are giving this is also some subsidy now.
In EVs also they are having subsidy. We maintained water at 140 degrees Celsius and 140 degree Fahrenheit, and we use the complete cleanly process and hygienic process in a poultry case by using hot water itself. Okay, this is how the PV systems are evolved into an agricultural, and avoiding the conventional fuels. What are the disadvantages and drawbacks of conventional fuels rather than a solar alternative in a renewable energy, and in which situations it will be used. And next, coming to agri PV, this is the agrivoltaics. This is known as agrivoltaic. Agrivoltaic is a thing where we are using land. Land is available for crop irrigation purposes. The same land is used for solar and crop irrigation also. For bidirectional purposes, we are using the land. The land will be used for dual purposes. One is for solar generation. The same land will be used by uplifting the solar panels from the ground level by using different different modes. And beneath this particular solar panels, we have a agri-tech land also. The land will be used for agricultural purpose. This is called as agri PV, or generally it is used. This is called as agrivoltaics. That is the theme which is useful in most of the scenarios. Agrivoltaics, where we are using both the purposes. The land will be utilized for agricultural activities, where the farming will be done, the complete farming will be done, whatever may be the crop we have, the complete farming will be done. If a crop is having some specific height, if this is a rice crop, there will be a specific height measures will be there. Up to this particular height, the paddy field will grow. Beyond that paddy field growth, we are installing the solar panels. And again, the same land will be used for solar installation and the land crop irrigation purposes. In these cases, the same solar energy which is available at this particular solar PV installations will be used for agricultural purposes, for cultivation and livestock management and aquacultures. Most of the cases we use aquacultures in fisheries, like fishing ponds. In the fishing ponds also we use floating solar panels. There are three types of agri solar panels will be available. Agri PV available. These are the various components of agri PV. One is direct the photovoltaic panels will be available. The mounting structures will be erected on a cropping land, and above this mounting structure, we are installing the solar panels as a solar farm. As like wind farm, it is a solar farm or PV farm. And there are some inverters for purposes of alternating current. Generally, the photovoltaic panels or solar panels will give DC energy. The DC energy is converted into AC energy by using inverters, and some batteries for surplus energy, and some IoT devices, sensing and IoT devices will be there for monitoring purposes. How much energy will be there, at what time the maximum power will be available, how the solar panels has to be tilted, the tilting angle has to be monitored and modified, controlled based on the maximum power point tracking algorithms in the solar case. And there are some situations like partial shading effects also considered for those solar energy generation. These are the three types. There is the crop production. The agri PV will be of three types. We use agri PV for crop production. Beneath the solar panels, there will be a crop. And in another case, animal husbandry. In the case of animal grazing field, if a grazing field will be available for a sheep or a cows, for that grazing fields also mounting with a solar panel for animal husbandry, and some ecosystems like vegetable plants and greenhouse plants or greenhouse paddy fields. In those situations also, we installed a roof mounted or rooftop solar panels will be available in different situations. This is a basic grazing, and this is some elevated purposes for animals which are high, which are having some height enough. Okay, these are various three cases. In these three cases, we have a ground mounted PV. Ground mounted PV means having a crop to be grown, and above the crop we have a PV systems or panels will be installed at a particular height. And the another one is a rooftop solar, where different buildings in agriculture like poultries and piggeries and greenhouses, all these are different buildings available in agricultural scenarios. In those situations, we use rooftop PVs, and then floating PVs like aquaculturals for fisheries and so on. For those situations, we use floating solar panels on a water surface. We use floating solar. The major advantages of using these things, and another one is integrated greenhouses with a solar panel. Mostly we are using these three cases. The major advantage is in first case, for a ground mounted PV, where we are allowing crop to grow under the solar panels, so that the moisture content inside the water, inside the earth, the soil moisture will be maintained perfectly, and there are UV rays and some of the so wow. We can also avoid that from the pollution. Also, we avoid from the bird cases. Most of the scenarios in a conventional scenario, we use some wire strings which are available in the crop field where birds are avoided. While yielding at the time of yielding, most of the birds are damaging the yield process. In those situations, most of the fisheries, ponds, and then agricultural lands will be covered with some nets. And another tension wire. Heavy tension wire will be available for the avoidance of that birds and different insects. Those will be avoided by installing those panels. Above the cropping field. That is first advantage. And second advantage, soil moisture will be maintained always. And in rooftop solar also, the complete energy needs will be met by this rooftop solar energy in an agricultural building, because most of the cases in agricultural buildings, the lightings and different fans will be available. For those purposes, we are using electrical energy, where that electrical energy will be transported from distance places. That will be a very costlier process. That costlier process will be nullified by using a rooftop solar. And by using this rooftop solar and supplying agricultural buildings with some energy by storing the solar energy at the morning time and providing lightning, some of the fields like your flowers and some of the fruits always have light, like a dragon fruit. For that dragon fruits, for yielding better yielding and better productivity, they always focused onto a lights. The focus lights will be exposed onto a complete plants in the case of greenhouse planting. In those situations, we use these solar panels for cost reduction cases. And in floating PVs also, we reduce the evaporation of oxygen levels inside a dissolved oxygen, and some for livestock, for fisheries and some prawn pits. Prawns, in those situations, most of the cases, the aquaculture, where they have disadvantages of evaporation of different gases which are available in that particular water, and the minerals, oxygen levels also decreasing. For that, they use always the rotating machines, fans will be there, and that fans will be monitored and managed at different situations. That evaporation will be reduced by using a floating PV on a surface of the water. This I covered. Dual land uses, benefits of agri PV. Dual land uses, energy independence will be there, and then climatic resilience will be there. Reduced heat stress and sustainable practices will be available for different cropping purposes by using agri PVs. And these are the various challenges why farmers are not initiating the solar based agri PV, mostly agri PV. Most of the paddy lands are cropping lands are unused. Most of the cases in our Indian scenario, in the belt of this 8 districts or 12 districts belt, this Krishna basin, most of the case this will be a cropland or a water-based or crop-based land. That complete land will be wasted without installing any solar installations like floating solar or agri PVs. They are not come forward and install solar PVs or solar PV based agricultural systems. They always follow the conventional scenarios which were at the olden days itself. Why it is? The challenges are the cost is very high for installing an investment, installing the complete solar panel. If I have a 1 acre land, for a 1 acre land I want to install solar panels, it is very much costly. That is the first thing. And another one is technical expertise. They don't know how to operate, whether they mostly afraid of this energy which is generated by this particular solar energy, whether if they are always depends on that particular solar energy, they want energy at right time. If the energy storage is not available and the storage is very less in those situations, they don't have technical expertise for how much energy of solar panels, how much energy storage will be given, and how this energy storage will be maintained. That is not done by farmers. There is no technical expertise to manage and maintain the systems of different solar panels, and they always want land usage conflicts. They want to balance the energy. If I want to use agri PV, then they want to always balance the crop yielding and the energy production also. Then only that will be very economical. They want to balancing energy production and agricultural also. That is very complex for a farmer which don't have any technical expertise, and some policy regulatory frameworks which are restricting dual usage. Some of the government policies where they don't support for dual usage of lands in some cases. That regulatory frameworks also major drawback and major challenge. To avoid these challenges, we have different cases. To increase farm productivity, we have different sensors. By installing different sensors, rather than directly agree PV, we use some of the techniques of agri PV in the uh, crop yielding and the productivity also. For a farm productivity, we use different sensors like soil moisture sensor, imaging purposes, drones, IoTs. By using these all technology advancements into agricultural fields, such that we can manage each and every element of the crop, from soil to crop yielding and the growth of that particular crop, when it will be yielding, what is the percentage of yielding, and what are the various diseases which are available in that particular crop. By using an imaging process through drones and monitoring of those imaging scenarios and images by using image processing techniques, we use all these technological advancements into a farm productivity, like various inputs. We have to increase this efficiency. We have land, labor, water. All these will be transformed into different outputs like crop yielding, livestock management, optimization of different resources. That will be done by giving inputs to that particular farm or a farmer by using different sensors. The farm productivity will be increased. Okay, this is one case. And what are the different factors to increase farm productivity? What are the factors to be considered, which I discussed? First one is natural factors, where quality of the soil and the fertility will be very much essential. If I want to yield a particular crop at a particular location, I want to first provide a survey of that particular land, whether that land is useful for a particular crop or not. Some of the crops, like black mud and red mud, there is a different lands will be available, and some hilly stations and downstream stations will be there. Some crops will be very much essential or very much effective in a downstreams, and some crops will be very much effective in a hilly fields, like carrots, uh, potatoes. In these situations, most of the cases they use wetlands rather than dry lands rather than wetlands. Like that, we need to have a soil quality and fertility of that particular soil. We need to differentiate between soil, different soils. What are the various water resources available, availability of water, irrigation facilities availability, weather and climatic conditions, when the weather forecasting, climatic and weather forecasting has to be done by using these natural factors for increasing the farm productivity. Another one is technological factors where we use modern equipments rather than manpower. We have precision farming and we have different equipments, modern equipments for farming like different harvesters and different tools will be available for crops. Various tools will be available. These will also use by using a. These are also having energy usage, and by using solar panels at the top of a tractor or a harvester, we will see all these technologies in the next slides, where all these equipments will be powered with solar, and then use of this agricultural for PV systems also. That is another technological advancements for farm productivity and some human factors. So many cases, farmers are not educational enough and they are having a lack of skilled knowledge. We need to train them, and availability of labor workforce has to be major thing for farm productivity. We need to assess the availability of labor in the case of particular demography. In those situations, these are the different factors.
I have a question.
Tell me.
About the tractors. So 2 weeks back, I think government of India introduced the e-tractors.
E-tractors will be yes, sir.
Is there any subsidies given to the farmers?
For every electric vehicle, the government is initiating some subsidies, sir. For every, not only for agricultural based systems, even a normal personal cars also. For every EV based, rather than a normal fossil fuel, if you want to use a renewable energy, whether in the case of EVs or in the case of solar, wind, and another renewable energy cases, there are different schemes available for not only farmers, for every human being who want to use renewable energy, they give a subsidy. There are different schemes for each and every case.
AP government also drones circulated have been for Vijayawada.
Presently, most of the cases they use drones. In the case of Krishna floods also, in the recent floods in Vijayawada, in those situations also they supply food and basic needs by using drone technology. The governments are ready for technological advancements, but they want persons or skilled persons rather than a persons, skilled persons who work on that particular technologies. They would need skilled workers. Most of the cases in our scenarios, engineering scenarios, even though they are mechanical engineer, electrical engineer, computer engineer, they finally land in a software job. They don't want to upgrade their skills in technological developments. But the government is encouraging in all the aspects, not only in drone technology. Even recently, DRDO proposed one topic like swarm drones. By using swarm drones, they want to identify radar systems which are available from other enemies. What are the frequencies of radars and how that frequencies has to be captured by using swarm drones. In the drone summit also they exhibit swarm drones. Swarm drones are very small drones having utilized for a different application. The in the swarm drone case, they use reinforcement learning having different agents. One agent will be having one task, another agent will be giving another task, another agent will be giving another task. For each and every agent, one main drone will be there that will be leading drone, and there are some swarm drones corresponding to that particular leading drone. The complete decisions will be taken by this leading drone, and swarm drones will follow that decision. Like that, they follow drone technology not only in agriculture, they use in all the scenarios. In agriculture also, precision agriculture is one of the scenario. We have in NIT also we have one startup, Planet Research. They use services of drone for pesticide spraying and live monitoring of that particular crop, taking different photos in a different yielding processes, like 15 days of a particular sowing of that particular crop. After 15 days, after 30 days, after 45 days. For every crop, there is some period. After 45 days, this is the health of that particular crop. In the images, whether any disease will be available, that disease will be captured, and they use corpus of different agricultural books. They use natural language processing scenarios. That natural language scenarios like ChatGPT and Olama, these natural language models which are available in the free domain, they use those domains and take the knowledge of agricultural science into a farmer scenario. Farmer don't know what type of pesticide has to be sprayed for for which type of disease. They identify the disease by using an image and image processing techniques. Based on that image processing technique, they identify the disease. For this particular disease, these are the pesticides has to be sprayed in this proportion: 40% nitrogen, 40% ammonia, 10% water, like that. They give suggestions of individual farmers, even though they are unskilled and untechnical persons. They are giving suggestions also. That is already done in various scenarios. Drones. India is not using drones, sir, but India is preparing missiles which can predict the enemy missile directly rather than drone. They directly came into a missile. Missile directly predict the enemy missile and smash that particular enemy missile based on the frequency they observe. The frequency which is followed, RF frequency, they always use radio frequency scenarios in a military applications. In those cases, there is some frequency of India. If there is another frequency which is available in that particular war field, then they want to smash that particular missile. That already done in Indian scenarios. In present day scenarios, we use all the techniques, not only a sensor technique, drone techniques, and a solar based tractors, that is renewable energy based equipments for the farming, but we are using machine learning techniques also by using a historical data of a particular farm or of a particular crop. What should be the health of that particular crop? What should be the diseases which are available at that particular season? If a crop is available at a winter season, for that winter season, what are the diseases they might affect the crop? They have different historical data. Based on that historical data, the machine learning processes will be done, and they predict the previous future analysis will be predicted by using machine learning cases based on the historical data, and give alerts to the farmers also, even though they are not well educated and skilled workers. And these are the economic factors. Market assessment for different government support subsidies and schemes, and then investment in research and development, like different research cases. And these are the factors affecting farm productivity, and how this farm product will be increased by using a agri-PVs. The major focus is on agri-PV or agrivoltaics. By using this agri-PV on a farm, how the productivity will be increases. One is the impact is there are different impacts. One is shading effects. There is a shading effects in both cases. Positive scenarios and negative scenarios also there for a shading effect. For a positive scenarios, they will reduce the heat on the crop. If it is a summer season, the heat will be very high. That heat stress on the crop will be reduced by using a solar agri-PV, that is PV panels which are available on the top of a agricultural land. That is positive effect or positive impact, whereas negative impact, negative impact corresponding to this particular shading effects by using agri-PV is excessive shading, where if I install solar PV panels on a crop, if they have excessive shading of the particular solar panels, more you need to install solar panels in a specific distance scenarios, specific distances, and the crop has yielding the process by using a photosynthesis only. That for photosynthesis, we need to have a abundant sunlight need to be focused on to the crop. That will limit the excessive shading based on the agri-PV. The excessive shading will limit the sunlight on the crop, so that some of the sun-loving crops, like some based on sun only, they yield fruits or any vegetable plants. In those situations, sun-loving crops, they limit the sunlight of this particular excessively. This is the negative impact of shading of agri-PV, and the positive impact is we have a maintaining the solar moisture and heat stress will be reduced. Whereas next effect is effect of agri-PV is using the same land for dual purposes, simultaneous cultivation and energy production also. We need to manage the cultivation and energy production. Both are managed together, such that optimal values of energy has to be produced, and the yield productivity will also increase by using dual land usage of agri-PV. And then energy for farming activities, the complete energy needs will be met by using solar installations on a agri-tech or a crop land. The complete land will be complete energy needs, like for irrigation purposes and different pumping systems, dryers, coolers, and whatever may be the case it is. We use environmental farming, and we always use solar by using agri-PV on a farm. And another one is microclimate creation. We can create different temperatures, regulate the temperatures and reduce the wind pressures of particular crop on a particular crop, so that the crop resilience will be increased. These are the various impacts of agri-PV on a farm productivity. There is one case, farm productivity is one case. Another case is how the technologies advance, how the technology advancements are useful for a agricultural case in case of solar energy. I already discussed by using IoT, integration of IoT and smart farming techniques. Like smart farming in the sense we use sensors for different applications, for soil moisture detection, for heat detection and temperature detection, weather forecasting. For all these scenarios, sensors for agricultural needs, and all these purposes we use solar systems only. Irrigation needs under solar PV only. And another one, solar powered equipment, all the tractors, water pumps, drying units, all will be powered by solar, so that the emission will be reduced, carbon dioxide and carbon monoxide harmful gases emission will be reduced, and the cost will also be reduced because of solar power which is used. And then energy storage, where batteries are used for energy storage for consistent operations of different different energy applications of agriculture. These are various technology enhancements. And coming to economic benefits, how economical the solar PV integration into an agriculture. Already given, reduce input cost. It will reduce the input cost corresponding to energy expenses, and we need less water and less pesticide usage, so that to regulate the climatic situations. And we have an additional income by integrating the complete solar farm into a grid scenario by applying a net metering system and connecting to a grid. Excess energy, which is surplus energy or excess energy, which is supplied by the or produced by the solar, will be again given to a grid, and additional income will be generated by the farmer. And some of the financial resilience will be given. Some farms have less vulnerability to the market fluctuations. In those situations, for different climatic changes, we have a diversified income sources for application of solar PV in case of agriculture. These are economic. I list out all the cases: farm productivity, in farm productivity, how the agri PV will be there; in technology enhancements, how the PV will be taking their role; and then economic benefits. What are the economic benefits we have by using solar PV into agricultural lands? And challenges we already done. And another case, sustainability aspects. We have three different pillars: socio-economic and environmental cases. If I need these three, if I met these three, then our agriculture will be named it as a sustainable agriculture. Sustainable agriculture by using the solar panels. These are the three pillars. First one is environmental. We have reducing the negative impacts on the ecosystem by reducing the emissions, bad gas emissions like carbon dioxide emissions, and we reduce the greenhouse effect. Greenhouse effect has to be reduced by reducing the emissions. That is environmental case. For an economic case, the farmers will be profitable by ensuring these solar PV integrations into the agri-tech, because the complete energy needs will be met by the solar PV, and the farmers will be having very much profitable and by increasing the productivity also. And social needs, social aspects, we have enhancing community like well-being and equity by overcoming these three, by having environmental, economical, and social. The solar PV application to agriculture will be a sustainable agriculture, sustainability in agriculture, which will meet the current needs and having different future abilities also. These are various integrations of renewable energy, not only in case of solar. We have a decarbonization by decreasing emissions, by using fossil fuels. We have different gases will be released onto the environment. We reduce that emissions. Decarbonization will be the case, so that decarbonization of agriculture will be possible by using PV systems in the agricultural scenario. greenhouse affecting gases will be reduced, and net zero goals will be achieved, and energy independence will be there for the farmers by applying solar PV. There are some sustainable goals for a uh, United Nations will give sustainable goals. There are 15 to 17 sustainable goals will be there. For every process, we need to meet any of those sustainable goals. Like education also, quality education is one of sustainable goal, and imparting skills, technical skills, and imparting technologies into that particular engineering students. That is STEM education we always follow. Now that STEM education is always renamed as STEAM H education by including maths and health also. Likewise, for every need, we are applying solar PV into the agriculture. How the sustainable goals? What are the sustainable goals will be needed meet by using this agricultural PV systems?
So I have a question.
Okay.
More pollution, so the surrounding areas.
Which one is more polluted? Delhi. Okay.
So nearby easy agriculture products are because of that only more pollution is there. Is there any solution provided by the factories? I think one way is because of land agriculture products only more pollution is there in the area.
In that scenario, rather than agri PV is completely for agricultural scenario. You are telling a metropolitan city like Delhi having more pollution. That's why they initiate EV vehicles rather than a normal vehicle like fossil fuel vehicles. They want to completely renovate the complete city with the EV vehicles so that sustainability will be increased for that particular pollution case. And another case, for each and every industries, they are utilizing renewable energy sources. Most of the cases, the pollution will be done from industries itself, and in that industry scenarios, those some of the energy needs, not all the energy they cannot met, because most of the production process and biomedical industries will work in the night 24/7 work. In those situations, they cannot meet the complete energy, but some of the energy will be met by using renewable energy sources so that the emission of unwanted and toxic gases into the environment will be reduced. That is one initiative. They already started, and they also use smart technologies like waste to energy. The complete municipal waste will be collected by the municipality itself and treated that municipality waste. There is no waste which is spilled onto the roads and anything. Complete waste will be recycled away and converted into energy. That is another renewable. And also they recycle plastic-based products which have a contamination of water and contamination of air. That's by taking all these initiatives, they will meet sustainable goals and they increase the environmental impacts, like increase the environmental scenarios. That is only the thing. By using agri PV, we can able to meet the agricultural needs rather than city needs. We can use a PV system for agricultural needs. Okay. This is completely for agricultural needs, not for a city need. City need they use a rooftop solar. These are the major advantages of solar PV by reducing carbon footprints, CO2 will be very negligible for by using solar PV rather than a diesel based any fuel based energy source. And some carbon sequentialization, that is soil management, crop management and soil management will be increased by integrating PV. That is that can enhance carbon capture. There is one example which I given. 30 to 50% carbon dioxide emission will be decreased on the farms if solar powered irrigation will be implemented. Okay, there is one study which is already done. And all these situations we call them as agrivoltaics by by integrating photovoltaic systems in an agricultural system. We use that is agri PV or agrivoltaics. Okay. Another scenario, we use solar PV panels for water conservation. For reduced evaporation, we use PV panels which acts as shielding on a water surface, that is floating solar panels. Floating solar, which will minimize the loss of water from soil and evaporation of water from the soil in the crop case, and maintain the soil moisture in the paddies by reducing the evaporation. This is one scenario by using agri-PV. And another one is efficient irrigation. By using solar power pumps, we have a high efficiency and optimized water usage by using solar power pumps and some drip irrigation systems. Most of the cases, water will be wasted in agricultural irrigation processes. Most of the water will be wasted. That will be nullified by using drip irrigation systems. Most of the crops will be using drip irrigation systems. Whatever water needs will be there, that needed water will be supplied to that particular crop by using drip irrigation. Again, in the drip irrigation process also they involve technologies like sensors, soil moisture sensors, and at each and every plant and each and every paddy field, they given soil moisture sensors, and based on the soil moisture level, they supply water from the pumps and tubes corresponding to that particular drip irrigation process. And we always maintain between water, energy, food maintenance. So our efficiency will be maintained between these three: water, energy, food, which will increase by using PV, where we have a high food production will be there by using solar PV in agri-tech. Next one is soil quality improvement. How the soil quality has to be improved by using PV panels into the agricultural systems. One case is erosion prevention. We can reduce the water erosion or water evaporation by stabilizing the soil which is available underneath the PV panels, where we reduce the wind completely, we reduce the wind and water erosion by using PV panels, and increasing organic matter, because the shaded region will be there. That shaded region will increase the microorganisms to live longer time. Some of the bacteria, microbial bacteria, which is useful for a crop in the crop case, will be alive in a shaded regions only. For that case, that increased organic matter or microbial activities will be increased in the case of shaded regions rather than a normal sun-based regions. And we use regenerative practices by combining PV systems into the agri-tech. And these are the sustainable energy goals, which are 2, 7, and 30, will be met by using solar PV into an agricultural system. Second one is zero hunger by increasing the productivity of farm or a productivity of a crop corresponding to that particular solar PV based systems. We increase the productivity, and zero hunger can be addressed. Sustainable development goals will be addressed by you increasing the productivity, and affordable and clean energy will be there. Always we use solar by using solar PV in remote locations also, so that clean energy will be using. There is no emissions will be there, and environmental impacts will be very less. And there are some climate actions will be there. We mitigate reduced emissions will be there, and we always use green energy or clean energy by using solar PV integration to the agriculture. These are the three sustainable goals which we met by using agri PVs. And this is the life cycle assessment. If I have a solar PV which is installed on a agriculture, how that will be used? Life assessment of that particular solar PV. Most of the solar panels they give warranty or low maintenance up to years of 25-30 years. Solar panels won't have any maintenance, and they will produce energy corresponding energy needs of agricultural land or agricultural case up to 25 years, 25 to 30 years, so that we can increase the production by using different energy scenarios for PV panels, by using PV panels. And we also recycle the PV components after this life cycle. We can also recycle these solar panels. Economic sustainability and climate is also already covered. This is also covered. And some of the challenges where we have a end of life management of a particular panel, and some initial costs. Most of the cases, farmers will be afraid of these two cases: end of life, land usage provisions of a particular country, and the initial cost of the particular solar panel installation. That is the major thing. And these are the recommendations for increasing sustainability, where SAR is asking for government subsidies. For subsidizing cases, government is also giving incentives and collaborative research cases. Some of the collaborative researches will be done in the case of different industry and academia case. They collaborate and provide innovative solutions for different agricultural needs, and they also train farmers, because the farmers are not skilled workers to manage and maintain these PV systems on top of the crop, and how to manage, how to increase the productivity also they don't know. So for that they educate the farmers by using trainings on farming techniques and different PV management techniques. These are the initiatives done by the government sector, recommendations and initiatives, and these are various cost savings. We have operational cost. I taken as simple example scenarios. By using solar energy, we install a 10 kilowatt PV system, which can save $2,000 annually. That is the energy cost. Where for an average farming case, if I increase the solar PV case, and this will be increased, the annual electricity price will be increased based on the farming techniques or farming equipments which are used in the farming base. And we also reduce the water cost by using water pumping system and by using water pumping in the case of solar, and some additional income streams where solar surplus energy will be selling at a different tariffs. Farmers will earn some additional income by supplying or exporting the solar energy to the normal grid scenarios. And dual land usage, carbon credits also there for farmers. Sell and credit the carbon. Great. I have technology, machine learning based techniques will be there. That we will discuss after.
Dear participants, take a break of 10 minutes and again session will start.
కూడా నేను ట్రై చేస్తే పెట్టాలి. Okay. These are the various case studies. I just discuss various case studies where solar studies, agri PV is installed. Where agri PV is installed in various countries. First case study is on Japan, Japan solar sharing, where they introduced the combination of renewable energies generation with agriculture, like agrivoltaics. They use agrivoltaics at the top of the crop field. They use solars. They use solar panels, and based on that solar panels, farmers install. impacts of this solar sharing project, where a farmer in Chiba, they produce use solar panels above the crop, which is Spanish and lettuce. These are the two crops they want to yield and generating energy while maintaining the crop agriculture yield also. They increase the key impacts will be 20 to 30% shading will be improved for crop growth by reducing heat stress upon crops like spinach, and they have additional revenue for selling excess electrical energy to the grid, and they use limited arable land, that is very in a very less land they have more dense populated case of solar and photovoltaic systems they are using in this project. Japan's solar sharing. This is first project, and second one is Germany. Germany is also using solar PV, agri PVs, where they are using vineyards. They use vertical PV panels rather than a normal PV panels at the top of the agriculture. They use vertical PV panels. Install a vertical PV panels, and the key impacts will be there. Key impacts will be they have a quality of grapes. They use for a vineyards. In a vineyards, they increase the quality of grapes by maintaining the quality of grapes. They have they use from excessive UV exposure. They protecting vines from the UV exposure by installing this vertical PV panels, and they also generate solar energy and complete vining operations, winery operations, the complete mortars, chillers, and all cases in a winery operation will be run by using a solar power, which is installed in the agri plant itself, and they reduce water evaporation by shading the soil. These are the three key impacts by applying agri PV on a vineyards in Germany. This is second case study. Third, India's solar pumping system. Solar pump, they use solar for pumping system. For pumping, they use solar, and they store water in in place called Rajasthan. They adopted solar powered pumps, and they store water and improve the efficiency of water usage and reduce carbon dioxide emission by using solar PV for pumping of water systems. Some person asked, this is the case where real scenario is done, water pumping system. And they also cut down the fuel cost up to 80% by increasing the efficiency, water usage efficiency. This is another case. For this solar pumping installation, this farmer have a scheme called PM Kusum scheme. There is a scheme, central government scheme. By using this scheme, they have some subsidy also available. Okay, PM Kusum is the scheme name. By using the scheme in Indian scenario, they have some subsidized cases. They use for wheat and mustard plant crops. There is third case study, that is India. Fourth case study in France. Again, they are using solar PV itself. They use in southern France. They install semi-transparent solar panels where they have partial sunlight and partial shading of solar. Solar panel sunlight penetration will be partial, and shading will be partial based on the usage of transparent solar panels. They increase weather-related damages for the crops. Weather-related damages will be nullified in the crop, and they increase generate green energy and enhance yield consistency and regulated light conditions also by using this transparent solar panels. are grazing with a particular perimeter. For that sheep grazing land, they use solar panels, and they prevent overgrowth of that particular grass inside a sheep grazing, and they don't have any regular maintenance, cutting off the grass into a particular level and so on. And also the livestock has to be maintained, and also the sheep has grazing the land in a shading scenarios rather than a outside environment. That is the major cases. They save cost, and additional income will be generated from livestock, and again they generated enough renewable energy. This is the fifth case. And sixth case, in China, they also use greenhouse model. By using a greenhouse model, they use solar for greenhouses for production of tomatoes and cucumbers. In tomatoes, cucumbers will be always farming in a closed room scenario. That is a greenhouse case. That greenhouse will be again lighting up, and energy generated corresponding to that particular greenhouse for lighting purpose and heating purpose. They use solar panels at the top of the greenhouse in China. This is another scenario, and these are the major challenges which will affect in implementing agricultural PV systems. Some of them are already covered in the previous slides, like high initial cost, land usage conflicts, technical barriers, environment concerns, social acceptance and awareness, climate and geographic limitations, infrastructure deficiencies, economic viability concerns, cultural and behavioral barriers. These are the various challenges to implement agricultural PV systems in any farming land. And these are the innovations and solutions for those challenges. To meet the challenges, these are the innovations and solutions, where the first one is advanced PV panel designs. Rather than a normal PV panel, they use advanced PV panels, that is bifacial panels. Both sides solar panels will be there. Nowadays, that bifacial solar panel research is very much interesting. Bifacial, both sides, they increase the by capturing the sunlight on both sides, they increase the energy efficiency. They will increase the energy output by reflecting environments like snow, sand, and so on. Some of the solar panels, there are two types of solar panels will be there. Tell me. Generally, these bifacial panels are useful only in the case of snow and reflective surfaces, not in a normal paddy field. In a reflective surfaces, there are two types of solar panels are available. One is polycrystalline and another is monocrystalline. Whereas coming to a polycrystalline case, if a light is incidented on that particular polycarbonate or polycrystalline, then it is generating an electrical energy only. Where monocarbonate or monocrystalline cases, if there is a heat energy available in the summer case, up to evening 7:30 p.m. or 8 p.m., heat will be there. Due to that heat also, they will generate energy, electrical energy from the heat energy. In those situations, by using that monocrystalline patterns, monocrystalline solar cases, they construct bifacial panels where there are some reflective surfaces. If a sun is incident on a sandy case in a sand surface, then there will be heat waves reflected on a snow faces. Snow faces also heat is reflected. In those situations, in both the cases, both the sides of a solar panel, there will be a capturing of rather than sunlight, they will capture heat energy and convert this heat energy to energy. Bifacial panels, they use mostly in reflective surfaces. And another case, advanced PV panels, transparent PV panels also they are using. In are the applications. They allow sunlight to pass through like this, yeah. Horizontal only. Horizontal. Generally, with a tilt angle, sun will be reflected directly on that one face, and reflection of sun heat energy will be reflected onto the other face. In both the cases, energy will be generated. In the case of transparent PV panels also, this is another scenario in advanced PV panels. They allow sunlight to pass through the solar PV panel. In those situations, most of the cases they use greenhouse crop. For a greenhouse crop, generally they use plastic based transparent sheets will be available, or nets will be using for sunlight to be passing through the nets onto the crop growth. To avoid to have a same scenario, they use transparent PV panels in the greenhouse cases. At the top of or at the rooftop of the greenhouse phases, they use transparent PV panels where it will produce energy while supporting crop growth also. Okay. And another one is flexible solar panels, which will be lightweight, adaptable, and in uneven surfaces also they are using. One scenario is more crops, crop rows, or portable setups, small scale farms. In those situations, we are using flexible and flexible uneven surfaces cases. Solar panels will be using. In those situations, we use flexible solar panels. And some advanced energy storage systems are also done. One is battery integrations. Integrations of some lithium ion and flow batteries. Examples are these two batteries. At the night time, we want to use the energy which is stored in the daytime. We are always storing excess energy of solar by using cloudy days also. By using this battery integration. So in the cloudy days also we can store energy. By the excess store energy will be using in cloudy days and the night time. And we are using lithium ion and flow batteries like liquid based batteries we are using. And then hydrogen. Nowadays, hydrogen fuel based batteries are also there. Hydrogen fuel based vehicles are also available in the present day scenarios. That hydrogen is also one of the storage device. By using this hydrogen gas, the storage will be done. The energy, converting solar energy will be stored into a hydrogen storage rather than a lithium ion battery or a liquid battery. These are two cases for battery cases. These are the advanced technologies. And some smart farming technologies will be there, where we have a sensors which are available. Sensors and various devices will be connected to PV panels, and we will track the energy production, crop health, and environmental conditions will be tracked. Based on that, we are producing alerts based on the irrigation. Okay, alerts will be producing, and that alerts will be sent to the user or a farmer in regular time basis. And we are using optimization and machine learning based algorithms based on the previous data, improves farm management. I will show you the predictive analytics corresponding to a particular energy data, optimizing energy or crop energy, crop data. There are different crop data will be available, and energy data will be available for PV. For predictive analytics, what should be the energy at the next 1 hour or next another 1 hour based on the environment impacts and irradiation values corresponding to a particular location. If I take a location called Vijayawada, it has some solar based illumination patterns will be there. If I go for a Ooty, or if I go for a hilly station, another hilly station like Tirupati, then they have some other solar pattern. Based on the solar pattern which is available in the previous history, they will produce predictive values of energy by using machine learning algorithms, and improves management of farm corresponding to that particular predictive analytics. And they are using robotics also, like robotic weeding machines, seeding machines, and harvesters. Rather than using a manual labor, they use robots for weeding, cutting, weeding, sowing, and then harvesting of that particular plants. They are using solar powered robots. And they use tracking PV panels also they are using, where the tilt angle will be adjusted based on the sunlight. Based on the sunlight, tell me, sir.
Tracking will consume more power from tracking in panel. Instead of generating more power,
Ah.
the motors used for tracking the sun will consume more power. How will you balance that?
Tracking based on the there is two cases, sir. We can use tracking based on the motor which is fixed at the center of a particular solar panel. That is one case. There is a case called mechanical tracking also there. Rather than using a motor, there is a mechanical system which is implemented on a solar panel, bottom of the solar panel, where based on the algorithm or MPPT algorithm, this mechanical tracking system will tilt the angle also. If you use a mechanical tracking system,
My question is how much power it will consume for this tracking?
the power is very less only, sir. That is a small servo motors they are using, small DC servo motors. That is based on the solar panel weight. If the solar panel weight is more, that's why we use transparent panels to increase the energy efficiency or increase the energy output by using bifacial panels, by using transparent panels, by using lightweight panels. That is the advancements of solar panel for reduction of that energy. Okay. To manage that energy, we use advanced techniques.
Sir, usual LTE method is used. Its mechanical step will be reduced.
Using tilting mechanism.
LTE method is used. Rather than say that its mechanical step will be reduced. Which mechanical step? That PV panels structure mechanical step.
How PV panel structure we cannot change, no?
Tilting we provided.
We have provide tilting.
The provided tilting means its mechanical step will be less.
Okay.
So rather than in agriculture fields, maybe it will be more. So how to prevent?
Agricultural field, wind will be okay. How to manage that mechanical stability? Okay, fine. In the case of tilting mechanism, we are using the complete solar panel with a mounting structure, sir. Rather than completely the solar panel will be burdened onto a motor, we are using a mounting structure. There is a framing or framing will be there. That frame will be tilting rather than solar panel will tilt. The frame will tilt, and inside that frame solar panel will be housing. That is the mechanism they are using for a mechanical case of tilting mechanism. And for by using this servo motors also, servo motors for tilting mechanism. They always use servo motors by calculating the complete weight of the solar panel. That will produce a torque for a one step or 1 degree tilt. They produce a torque based on the weight of that particular solar panel, so that the mechanical strength will be maintained by the motor by keeping that solar panel in a hold position. That is managed. These are the two cases where autonomous and robotics will be used in the case of agricultural PV. And another one is floating solar panels are also used installed on the various ponds and reservoirs. Also, they are using floating PV panels. They use floating PV farms in one rural area in India also. they combine integration of PV and wind. In some cases, wind is more and PV is very less. If I have a farm at a hilly station wind is more rather than a PV systems. In the case of windmills also, there are different windmills available. In the previous olden days, a large turbines will be there, large wind mills will be installed. Nowadays, the efficiency of that large windmills will be very less. That's why they switch over to an Archimedes wind turbine rather than installing a large blades on a wind turbine. That will be an additional burden onto the wind turbine, so that they use the Archimedes wind turbine for a less area also it will produce energy. That will be very much useful in the case of wind case by integrating PV and wind case.
What is the height of this wind turbine, sir?
Archimedes wind turbine.
And what is the height of this thing? Normal windmills, they are very high.
There is no height perceptions in Archimedes wind turbines. In Archimedes wind turbines, we place in a top of your building also. That is fine. The construction of Archimedes wind turbine is in such a way that is in the spiral case. It is in the spiral. If a less wind is flowing, if there is no wind velocity also there is no wind velocity, very less wind velocity, even then, based on the mechanical structure of that spiral, it will produce a velocity. It will produce a pressure. If I produce a wind on a small nozzle, it will produce a pressure. It will increase the pressure. Likewise, the mechanical structure will be designed in such a way that it will be in spiral case. A small wind velocity will increase the efficiency of that particular wind turbine. That is the major thing. If you install that wind turbine, that is Archimedes wind turbine in the top of your building, it is more efficient rather than a solar panel also. It will produce 24 by 7 energy rather than only morning time, only night time like that. Because wind is available every time. So that it is a better alternative for solar. Solar is having only 10 hours of energy will be there. Among the 10 hours, only 3 to 4 hours will be the maximum power point time. Because the sun will be at the top of our head, that is at the middle of your building. The most energy will be captured at that 3 hours or 4 hours only. Remaining all other cases in the morning time and in the evening time, based on the partial shading effects of that solar panel itself, the energy will be very less. If I install this wind turbine, Archimedes wind turbine, that is the alternative for solar.
And what is the cost of installation, sir, compared to solar?
Cost is mostly similar.
Similar.
Mostly similar for wind turbine.
Is it available
Per kilowatt wind turbine. It is available.
in India?
Not only in India, everywhere it is available. That is available in NIT also. NIT Kandapalligudam, we have a Archimedes wind turbine. And some of the cases we use vertical farming techniques also. This vertical farming is a fashion nowadays. Like different structures will be there. Vertical farming, like a small plants. They use vertical farming techniques and designing cases with the decors. For decors, they are using this vertical farming. Urban agriculturals, they use rather than a cultural lands, they use a balcony as a farming area. For that vertical farming also, they use PV panels. A PV panel will be mounted above that PV panel. If this is the PV panel, a vertical farming will be mounted in this. Vertical farming means a small cups will be there. In that small cups, which is erected in a particular fashion, plants will be growing. Okay. In those cases, they use some of the cases solar PV panels are also using for your windshields, elevations of building also. Okay, elevation of a building, generally glass will be there. Rather than glass, they use solar panel. That will generate energy, and that energy will be used for a building purposes, right? Building purposes, they use greenhouses with pre-clean integration. Top of a greenhouse, we use semi-transparent PV panels. Based on that, they use, and then advanced cooling systems. We use water cooling PV panels. That is, by using PV energy, we are supplying water and air, cool water and cool air for different purposes of climates. That is, for a particular crop, we use hot water, hot air, hot water, cool air. HV and AC systems has to be maintained in a livestock chambers by using PV panels.
Battery flow.
Sir?
రెండు తీసుకు సార్ అన్నింటిలో ఏదైనా ఉంటుంది ఇప్పుడు అదే అక్కడే ఇదా అన్ని అయ్యేదే
Okay. For smart farming and smart agricultural cases, we have machine learning algorithms to be used for different applications. ఈ పని చేయదేమో దాంట్లో PDF Now here we use the open source data sets which are available on the internet, where we have a agricultural data, historical data for crop yield prediction and analysis. There is one of the data, and they use US corn production, US based corn production data will be given in the case of crop yield product prediction and analysis. And second data set is soil health and quality. I already mentioned you need to get a survey of soil health and quality of the soil, fertility of the soil, while sowing a particular seeds into a soil. In that case, we analysis soil health and quality. This is the database corresponding to that particular soil health and quality for a particular place. And the third data set is pest and disease management. What are the various pests and diseases which are available in a crops, and what are the infections available in that particular plants? That will be the data. This is the data set. And then climate and weather data. What should be the historical climate changes? What are the historical climate changes corresponding to that agricultural fields in a particular field, in a particular demography? They are given a historical data. And then precision agriculture and IoT by using greenhouse emissions and sustainable agricultural. They use the data corresponding to precision agriculture and sensor data corresponding to IoT. There is another data set. And then crop price prediction. What are the various crops and what are the various prices corresponding to that crops will be given in this particular data set. And agricultural economics of an agriculture will be given in this. And livestock and animal farming. Livestock like piggeries, poultries, all those livestock data will be available in this. These are all agricultural data sets which are available in Kaggle database system. Kaggle is an open source database system. You can directly download these data sets. Any data set you can download and apply any machine learning based algorithms on these data sets to predict the yield corresponding to a particular crop based on the previous data, and by using a different machine learning models you can implement. Okay. In the implementation stage also, Kaggle is an open source system where you have machine learning techniques, ML for agriculture. If you type like this, Kaggle, Kaggle is open source for all the codes and data sets. This is the one scenario, machine learning in agriculture, where you have the complete Python library and Python code available for application of machine learning. They use ensemble models and the classification models like decision tree classifier, SVM classifier, and SVC classifier, random forest classifier, neighbors classifier, and then bagging classifier. These are the ensemble models. Random forest classifier and bagging classifier are the ensemble models, and the basic classifiers like decision tree, SVC they are using. These classification models are using on which data? It is crop recommendation data. For a particular agricultural land, what should be the crop recommended? They are giving crop recommended data corresponding to that crop recommended data. These are the values. What is the percentage of nitrogen, phosphorus, potassium, temperature, humidity, pH level, rainfall, and what is the crop which is recommended for that particular soil. This is the data set which is given. For this particular data set, they applied machine learning algorithms. This is the complete data set where what is the pH level, what is the rainfall percentage, and what type of crop is feasible for that. Okay. Now, this is completely exploratory data analysis. You can directly run this by signing into your Kaggle account. Create Kaggle account freely by using your Gmail account. You can directly log in into your Kaggle account, and you can run this base model, and you can extend further by applying various machine learning algorithms. In this data set, this is the nitrogen percentage, nitrogen plot corresponding to these nitrogen counts and nitrogen values corresponding to this data set. And another one, phosphorus, phosphorus values, potassium values, temperature, and then humidity corresponding to a particular location. They are collecting the data, rainfall, and various crops. The labels are, these are the various crop labels. What are the crop labels corresponding to a particular rainfall? If I have a rainfall which is between 10 to 100 to 150, then the crop recommended is which is on violet color, which is orange crop. Orange is the crop which is recommended for this particular rainfall. Okay. For a particular temperature, for a temperature of 45 degrees, this crop recommended is papaya. This is the color, na? Papaya. These are all various labels which are crops recommended for that particular rainfall and particular temperature. Based on a particular rainfall value in a region, we can able to identify which crop is suitable for that particular land. Okay. These are the various crops: rice, maize, and chickpea, kidney beans, and black gram, pomegranate, banana, mango, grapes. These are various crops corresponding to that particular. These are various data exploratory analysis. They didn't use any machine learning till this point, and after that, after cleaning of this process, for every data set, there are 3 steps involved. One is preparation of data. First, in the preparation of data, they want to preprocess the complete data by eliminating the outliers, missing data, for different plants, different labels also. Here they given grapes as label. For grapes, they have lower limit of 188 and upper limit of 212, and minimum value is 195 and maximum value is 205. And for a lower limit pass, there no need to remove outlier. For upper limit also, there is no need of outlier will be removed. And then if any outlier will be detected, that will be removed for corresponding labels. They given different labels. For different labels, they prepare the data. After completion of preparation of data, they want to apply or training the data. They need to completely take a raw data, clean the data, or process the data, and give it to a machine learning model for prediction. Okay, they prepare X is a training set and Y is the test set. Like that, they prepare and they use training test split by using 80% and 20%. 80% will be training and 20% will be testing. And they have the lengths of training test values as 1650 and 550 are the lengths of the various samples. Training samples of 1650 and 550 will be the test samples. And they use, these are the machine learning models they use: decision tree, support vector machine, random forest. These are the three machine learning models they are using. And they train on the trained data set and apply machine learning models. Model name is decision tree, and best score corresponding to that particular model they given 0.9848. You can directly edit this, copy and edit this, and you can run by your own. Directly in the Kaggle account itself you can run. No need of any GPU is needed. Kaggle environment will give a graphical processing unit of 30 hours in a week or in a month. Okay? Tell me. Data will also be changed. This is the original notebook file, sir. In this notebook file, here the data set is already uploaded. Now, the crop recommendation.csv is the data set, which they taken and recommend a particular crop based on the temperature value, based on the rainfall value in a particular location. If I want to upload another data, then upload new data set. Then you can upload another data set and apply the same machine learning algorithms on that particular data set. Based on the features of that particular data set, you need to modify the code. If the features are not same, corresponding to the already available data set and the newly uploaded data set, based on that you need to modify the code while pre-processing the data, cleaning the data, outlier detection, all the things you need to modify the code. Directly you can run this complete code here itself. You can run here itself. There is no need of any GPU, Python environment, nothing is needed. Directly the Kaggle itself have the complete backend support corresponding to all the machine learning and deep learning algorithms. Only thing is you need to sign in. If you sign in, I don't have any GPU here. Only HDD, CPU, RAM is there. You can able to activate your session with GPU also. Okay. The GPU is also needed for some of the data sets. File, some, yes, in run, you need to select a GPU also. And there is no possibility of selection of the GPU because I was not signed in. Okay. If you sign in, it will be showing here itself. It is showing itself here itself. Okay. Run by using a GPU sessions they are using. 30 hours of that, 30 hours of GPU access is given to any user, any login. you can directly upload data set and apply any machine learning algorithm which is already available and run the program. Directly run here itself. This was already run. Here itself you can run. Okay. This is how the data will be collected. All crop related data will be available, agricultural related data will be available in this link. This is the various data sets, and for these various data sets, the codes will also be given. For a particular data set, I want to use crop yield protection. This is the data set. Soil health monitoring. Is internet connected, sir? It is not opening. Google mail ID is there. Which one, sir? Atal. Now I have signed in. Here also I need to check. Given data set you pay. For that particular data set, the code is also available. This is the data set. This MMR. I want the data set corresponding to any one. It is not opening. Now that's this data set is open. International greenhouse gas emission data set is there. This is the characteristics of the data set. The size of the data set is 1.1 MB and there are 4 columns. And these are the various demographies, Australia, and then here itself you can directly download the graph in PNG form. After completion of a code, this is the download of data set itself, sir. In the code itself, I will show you the code corresponding to this particular data set. There are 10 codes available. Any one code I run. CO2 and green gas prediction by using machine learning. Here is the complete code corresponding to CO2 and green gas prediction. All the data sets which are available in that particular notebook will be available here. In input there is a data set, and from that link itself, Kaggle/input, the data set will be uploaded and it will be run. After running all these things, you can plot here, plot.show. You can also use plot.save. Plot.save. Then in one folder, all the plots will be saved as PNG. That folder can be downloaded directly. Or directly right click this, save image as some PNG form. You can save. Directly from this graph, you can save the image. Directly that PNG form image will be saved. Fine, sir. This is the result PNG. This will be uploaded to your papers also. Directly that paper, in the paper itself, you can upload this figure. The same figure it will be showing in your local folder. like this. This is the PNG file. The only thing is you need to identify, you need to make sure that the accesses will also be copied. Okay. Here the accesses will be there, but there the black color will be available. By editing that figure with other colors, you can get. For different scenarios, for different Belgium one greenhouse, Canada or Croatic, Cyprus, different various demographies, the data set is available and the complete data processing is done for different demographies. After that, we are predicting the CO2 and gas prediction corresponding to a particular location. This is the year and this is the emission in kilotons corresponding to annual CO2 emission and greenhouse gas emission corresponding to a particular year. We are predicting. Okay. And this is a machine learning model you are using for different demographies. You can run directly the code here itself and you apply various machine learning algorithms, and this is the demographies, country or area. Based on the country and area, you can able to predict CO2 and then CO2 DMD. This is the original data set and this is the discrete DMD, this is conventional DMD. Okay. These are the various cases corresponding to that particular data set. Like that, for every data set, there is a particular code. For every agricultural data set in the table, we have different challenges will be available, and in that challenges, different codes will be available. Take any one code, run that code. If the results are perfect corresponding to that particular code, apply your own algorithm, and you can implement that algorithm for the same data set. You can produce papers also. Okay, sir. This is how smart technologies or smart techniques will be useful for historical data on this is only the pure agricultural data set. You can also have PV data set. You can also have EV data set. PV also you have data. Solar power generation forecast. You have a code like this. You have a data set corresponding to solar power. For a particular solar power plant, this is the data set, and for this solar power generation forecasting, they use some machine learning algorithms. This is one of the challenge. They give a complete code. That is the beauty of Python, where Python is an open source tool, so that you can able to get every code in online. But in the case of MATLAB, if any one particular code is released today in MATLAB, we can't get on tomorrow. Because until unless the MATLAB persons or MATLAB software persons include a particular toolbox into the MATLAB environment, we can't get that particular toolbox. In a particular version only, the toolboxes will be available. Let us suppose for a deep learning case, 2022, they included deep learning toolbox in MATLAB. Below 2022, we can't implement deep learning using MATLAB. That is a drawback of MATLAB. By using Python, you can get various data sets along with codes, open source. This is an open source tool, completely free. You can implement any algorithm in this, any data set. Clear, sir? You can integrate, sir. Like that, data set is also available. Search the data set first, Because to implement a machine learning algorithm or a deep learning algorithm, you need data. If there is a data set availability, then you can implement any machine learning algorithm and deep learning algorithm. And some of the cases, some sensor data is also available, and you can able to implement real-time systems by using Node MCU or ESP32s, Raspberry Pi, or STM32 boards. By using that hardware systems also, by using sensor data, which was implemented through machine learning algorithm, and again export into the hardware model. In real-time scenarios also, you can able to get. Is it clear? Then articles are available in this laptop, sir.
In what?
To in my WhatsApp. In this WhatsApp, it is available. Ah, yes. With that, the first session, agricultural PV integration to agricultural and sustainability is completed. And the session article discussion, for article discussion, WhatsApp. These are reports. It is very slow. Okay.
ED1.
Not connected. It is having 33 pages, no? ED1 is having 33 pages. That's why you take that. Okay, fine. Wonderful. In article discussion session, we have an article, there is a review article where in a Maharashtra case, in a Maharashtra state in India, what is the various renewable energy mix is available in the Maharashtra state that will be presented. What are the present scenarios and what are the various future directions corresponding to that particular renewable energy in Maharashtra state that will be discussed in this review paper. And coming to this, they have renewable energy having in Maharashtra state, they taken renewable energy scenarios. What are the present scenario of a particular Maharashtra state when compared to a world case of renewable energy? What are the various plans, targets, and gaps, barriers, and challenges will be there that will be discussed in this paper. And coming to the introduction and literature survey, they taken different papers where they meet sustainable goals and various sustainable energy scenarios, renewable energy cases, or a world scenario. Various papers will be taken and discuss each and every paper. What are the various reports in different countries like China, Bangladesh, America, like that? They presented each and every country scenario when compared to Maharashtra state. And these are the major goals and main contributions of this paper to give a understanding of renewable energy scenario, which is in Maharashtra in terms of renewable energy resources for the development of state socially and economically. That is first contribution. And second contribution, they have a research which was carried out in an Indian renewable energy scenarios, policies and initiatives, and their studies by discussing and analysis with respect to Maharashtra state. And then they also discuss the limitations of Maharashtra state when compared to various countries across the globe. They completely segregated literature technological advancements and policy schemes of various countries, non-conventional energy status and technologies deployed in India. These are for global scenarios, and for Indian scenario, what is the non-conventional energy status? And coming to Maharashtra state, they taken a case study of renewable energy scenario in an India case. And upcoming green energy projects, what are the various upcoming green energy projects implemented by India and particularly to Maharashtra state, and what are the various analysis corresponding to RES potential in Maharashtra, and their research outcomes will be discussed in this section in various perspectives. These are the various proposed research works available. In first case scenario, they use non-conventional energy utilization by various countries. They taken different countries as a input. For different countries, they utilize. They have taken a non-conventional energy scenario for all these countries, like Ireland, Norway, Poland, like that. These are all the countries, and we have Indian scenario also. Japan and India. This is the Indian scenario. What should be the growth rate of solar energy for different countries year wise from 1314 to 1819? What should be the growth rate and in which percentage it will be available? That will be discussed in this section, and it will be clearly mentioned by using a bar chart. And another case, they also use rather than a solar renewable energy, they also predict or mention the growth rate for wind energy for different countries and corresponding years. What is the growth rate corresponding to wind energy? And then they discuss the various research articles and their GDP growth corresponding to renewable energy sources. They discuss various research articles here in this paragraphs by citing all those articles. What should be the various concentrations of solar panels, how the growth will be available in various countries, and how the installed capacity will be varied from year by year in that particular country. That will be discussed in this paragraphs. And then some policy schemes also discussed. For country to country, the policy schemes while producing renewable energy, electricity energy through renewable energy, there are some policy making corresponding to different countries. What are the various policies followed by various countries will be discussed in this particular section, like UK, USA, what are the policies, and then likewise they completed one section of literature survey. Next one is they mostly commented on non-conventional energy in India, Indian scenario, coming to from a global scenario, from a global perspective, they coming to an Indian scenario. What is the position of India in a growth rate of renewable energy from last 10 years? Okay. When coming to an Indian case, installed capacity will be given from 2009 to 2019. This is the last 10 years data. The growth rate will be year by year. It is increasing from last 10 years. Renewable energy resources in India. And they also mentioned total installed capacity by using various renewable energy sources like wind, solar, biomass, small hydro, wave. What is the percentage of that particular capacity in megawatt, which corresponding to that particular renewable energy source in Indian scenario for last 10 years also they have given. After that, from global scenario to Indian scenario, they narrow down. After that, from Indian scenario, they have taken a case study of a Maharashtra state. What is the energy scenario, which is related to renewable energy? in a Maharashtra state. Only they concentrate only in Maharashtra, various locations in Maharashtra. What is the various energy mixes available in Maharashtra state in megawatt case, and what are the various growth rates corresponding to that particular Maharashtra state. These are the solar cases, solar parks available in Maharashtra state, and their approved capacity and location where it is available. Okay, these are the statistics of Maharashtra state where it is concerned to only the solar energy. And they also installed in Maharashtra state solar based traffic signals are installed. What are the various challenges involved and different methods to improve the efficiency of that particular solar based traffic signals is discussed in this paragraph. And then solar heat generation, some of the cases they use the solar heat generation in some districts, some locations in Maharashtra state. For that, what is the installed capacity, what should be the collected area, and what should be the cost corresponding to that particular solar heat generation is discussed in this particular section. And then after solar, they move on to wind, various wind power plants produced, which are located in Maharashtra state only, in the various districts. These are the locations of Maharashtra state. What are the installed capacity and where it is available? That is given. Solar, wind, and then hydro case also there. What are the various hydro based cases? Because a river called Narmada is flowing in Maharashtra state. For that Narmada, they produce hydel power plant. What are the capacities of hydel power plant in various regions of Maharashtra state? They completely discussed in this. These are the various scenarios. Wind energy, what is the installed capacity from 2010 to 2020? What is the highest capacity they given? And then solar energy, and then biomass energy, solar small hydropower energy. What should be the installed capacity? These are all corresponding to a particular Maharashtra state itself they produce. And they also given potential alternatives rather than installed renewable energies which are available in Maharashtra state. What are the various potential energy resources which are available in near future? That is wave energy they have discussed. Geothermal, they can able to produce energy through geothermal for a coastal area, west coast. And what are the various feasibility sites for wave energy in Maharashtra? They have given cost analysis and all. Tidal energy also they have given. And corresponding to that particular Maharashtra state, the load curves and load demands also given. What should be the peak demand? When the peak demand will be available? For complete data will be taken from Maharashtra State Electricity Board, where the peak demand will be available, how it will be addressed by using a load shedding mechanism, by using a solar energy, by using wind energy, by using thermal energy, by using gas, by using hydro energy, like that. They given the statistics of all the load data in Maharashtra state. Hourly solar energy, hourly wind energy will be given. Like that, they completely discussed from a perspective of world scenario to a perspective of a particular state case study. They completely discussed the renewable energy installed capacities, what are the feasible alternatives in near future, what are the locations for that particular near future installations. They completely discussed in this particular paper. That's how the paper will be organized. Okay. with this, I end my session. Sir. ప్రాక్టికల్ కూడా చేయొచ్చు. ప్రాక్టికల్గా చేయాలంటే ముందు ఏదో ఒక సిస్టంలో ఏంటవి ఆప్టిమైజేషన్ కాదు, ఇప్పుడు అన్ని మిషన్ లెర్నింగ్ అల్గోరిథమ్స్ వాడుతున్నారు. ఆప్టిమైజేషన్ ఎప్పుడు అయిపోయింది. దాని ఇదివరకు పేపర్లన్నీ ఆప్టిమైజేషన్ మీదే ఉండేవి, అంతా ఆప్టిమైజేషన్ మీదే చేసేవారు అందరూ. ఇప్పుడు ఆప్టిమైజేషన్ ఎవరు పేపర్ని యాక్సెప్ట్ అవ్వట్లేదు. ఆప్టిమైజేషన్ చేస్తే ఇంకా ఆప్టిమైజేషన్ పక్కన పెట్టేయాలి. క్లాసిఫికేషన్ టాస్క్, డెసిషన్ ట్రీస్, ర్యాండమ్ ఫారెస్ట్, ఎస్విఎం, సపోర్ట్ వెక్టర్ మెషిన్. అవి బేసిక్ మిషన్ లెర్నింగ్ అల్గోరిథమ్స్. అవి కాక డీప్ లెర్నింగ్ అల్గోరిథమ్స్ ఉంటాయి. న్యూరల్ నెట్వర్క్, ఆర్టిఫిషియల్ న్యూరల్ నెట్వర్క్ అల్గోరిథమ్స్, కన్వల్యూషన్ న్యూరల్ నెట్వర్క్, పజ్జీ బేస్డ్ అనేది అది ఆప్టిమైజేషన్ తర్వాత వస్తుంది. అదే మిషన్ లెర్నింగ్ అల్గోరిథం. పజ్జీ మీద కూడా ఉన్నాయి సార్ పేపర్స్. పజ్జీలో ఇదివరకు అంతా మొండానీ బేస్డ్ పజ్జీ లాజిక్ వాడేవారు సార్. ఇప్పుడు అందరూ టకాకి సూచన వాడుతున్నారు. టకాకి సూచన కానీ, పజ్జీ టైప్ 2 సిస్టమ్స్ కానీ, టైప్ 3 సిస్టమ్స్ అని ఇంకా చాలా ఉన్నాయి అప్డేటెడ్ వర్షన్స్. అవి ఇప్పుడు బాగా ఎక్కువగా వినపడుతుంది. వాటిలో వస్తాయి.
ఇప్పుడు ఈ పజ్జీ లాజిక్ కూడా వేరే వేరే ఆప్టిమైజేషన్ అల్గోరిథమ్స్ యాడ్ చేసేసి ఇంప్రూవ్
చేయొచ్చు. వేరియస్ అల్గోరిథమ్స్ యాడ్ చేసి పజ్జీ లాజిక్ కూడా అప్లై చేస్తారు.
దాంట్లో ఉన్న డ్రాబ్యాక్స్ యాడ్ చేస్తుంటే చదువుతా ఉంటే ఎక్కువ దాంట్లో ఏం లేదు.
అదేంటంటే
ఎక్కువ చదివేస్తుంటే మనకేం లేదా అనిపిస్తా ఉంది.
అంటే రోజు అల్గానే వస్తుంది సార్.
కాన్సెప్ట్స్ కూడా అంత మళ్ళీ అంత డెప్త్గా వెళ్ళిపోతాం. మనకి ఇంకా లేదు కాన్సెప్ట్ అయితే అది మళ్ళీ అంత నేర్చుకోవాలంటే కూడా మళ్ళీ అంత చెప్పడాలి మనకు కాన్సెప్ట్.
ఎలక్ట్రికల్ వాళ్ళు ఈ వ్యక్తి రావాలంటే కొంచెం ఇబ్బంది.
కాకపోతే ప్రతి చోట మన అసలు అదే సార్ ప్రస్తుతానికి మన టీం ఏంటి దాంట్లో ఛాలెంజెస్ ఆ ఛాలెంజెస్ చాలా ఎక్కువ మనం చేసినప్పుడు దానికి తగ్గట్టుగా ఏదైనా మెదడాలు వచ్చేసినట్టు ఎవరైనా దగ్గర హెల్ప్ చేసేవాళ్ళంటే ఈజీగా మనం నేర్చుకోవాలి. సపోర్ట్
సపోర్టే ఇచ్చేవాళ్ళే లేదు.
కొంతమంది ఏమో మనం చెప్తే మన సీక్రెట్స్ అన్ని ఫీల్ అయిపోతుంది. అంటే ఇంతే అనుకుంటారు కొంతమంది. కొంతమంది ఏమో టైం లేక కొంతమంది అలా రకరకాలుగా
మీకు షేర్ చేస్తే అంతే.
కానీ ఇప్పుడంతా కూడా ఓన్గా నేర్చుకోవచ్చు, చావు నేర్చుకుంటే నేర్చుకో కాకపోతే అనగానే నీకు కావాలా నువ్వే నేర్చుకో, నీ చెప్పు నువ్వు పడి సపోర్ట్ అంటే తీసుకోవాలి ఆప్షనల్. కానీ నువ్వు ఎదుర్కొస్తున్న మాత్రం నువ్వు లీడ్ చేయాల్సిన ఇండివిజువాలిటీగా
ఇప్పుడు అంతా సెల్ఫ్ బేస్డ్
మన ఏంటంటే సెల్ఫ్ బేస్ చేసినప్పుడు మనం సక్సెస్ అయితేనేమో ఇంతేనా అనిపిస్తుంది, సక్సెస్ కాలేదు దాంట్లో బాబు చాలా కష్టం మధ్యలోనే రాకపోతుంది. మీరు అన్నీ తాగలేదు అట్లా నేను పాలిటిక్స్ చేశాను సార్, మా గవర్నమెంట్ క్రియేట్ ద్వారా దాన్ని మన ఏదైనా ప్రెసెస్ పెడితే లేకపోతే
Dear participants, now is lunch break. So all of you take lunch, and all of you after lunch, all of you assemble here. Thank you.
మధ్యాహ్నం పేమెంట్ అందులో ఛార్జింగ్ the Vadlamudi, SASTRY will go through all.
Good afternoon to the participants. So the morning session, that is sir explained the different concepts. So and also sir explained one software, so the which is useful to the research scholars especially for publishing the papers on the agri PV systems and electrical vehicles related. So sir explained the very beautiful way. So afternoon session now the afternoon session starts now. So the all of you interact with the sir. Sir has a knowledge. So how to publish the papers and so the he also he has industrial experience. So he worked in renewable energy sources. So I think one industry problem also solved by the sir. So that is all of you try to interact with the SAR and utilize the knowledge of your SAR. And now the second session starts now. So I invite the Dr. L. Sastry Garu to take the second session. So after the second session, the 4 to 5 article discussion 2 will be discussed. So I request all the participants try to submit the article discussion summary to my email ID. So that is I created the one email ID for especially for this Atal FTP program. So because if you send to my mail, it is very difficult to segregate all the PDFs. So all of you try to save the PDFs. So with the registration number, that is I have given the numbers 1, 2, 3 like that. So the total number of participants are 50. So therefore 50 roll numbers. All of you save the PDF with roll numbers so that yeah, you can submit the those files to the AACTE. So other thing is we'll send the feedback link every day, and also we'll send the quiz every day. So all of you note these points. So that try to submit all the required documents in time, so that yeah, you can get the certificate easily. So the we know the rules and regulations, that is the guidelines given by the AACTE to get the certificate. So that is a minimum requirement. That is a 80% attendance is required. So the, all of you try to attend all the sessions. So the yesterday we completed successfully all the sessions in the morning because of this online. We face a problem. After that, we rectified the problem, and finally today, so everything is okay. So all of you try to utilize this opportunity. All of you try to interact with the resource person, try to get the knowledge, and so we are already we I explained. So the 4 industrial visits are there. So the already we have get the permission from the all the industries. So the first industry is Josel. Next one is solar. So Bharati Solar Power Plant, which is located in Amravati, near to the Amravati. That is Android. The place is Android. Electronics. I think some of the faculty members visited. They told that we visited the electronics. So still they will explain. So the problems related to agri voltaics, voltaics. So that is a thing. Um, Next, these are 4 industrial visits. So that will enhance your practical knowledge. So the try to get the practical knowledge from the 4 industries. That is we planned the for 4 industrial visits. That is third, fourth, fifth, and sixth. The last day we don't have sessions. Last day we will try to summarize all the points. That is a summary of summary. So the next one is feedback. So the like that it will go. So the try to we group the all the 50 members. There is a five. We try to group of 5 groups. So each group they will at the last day they should come and present. So the all the things, that is article discussions summary. After that feedback. So everything should be completed in the last day. So thank you. All of you try to utilize this opportunity. So now I hand over the session to today's resource person, Dr.L SASTRY. Sir.
Okay, good afternoon, Anandal. Now the fourth session is on overcoming challenges in the integration of agricultural PV systems and EVs. In the morning session, we already gone through how the photovoltaic systems are integrated, or photovoltaic based agri systems will be designed, and what are the various challenges and different scenarios of agri PV are discussed in the previous lecture. Where now we would like to introduce an EV, electric vehicle, in agricultural scenarios, and integration of both electric vehicle and agricultural PV to a grid scenario, and what are the different challenges faced by integrating PV and EV. Coming to the electric vehicles which are used in farming or agriculture, there are various machineries which are used in electric machineries used in agriculturals. Those are uh, majorly tractors, autonomous electric drones, utility vehicles for transportation purposes, and irrigation systems like pumping, motors, pumps, and all. These are all the key types of machineries which are used in farming sector, in an agricultural sector. Now, I would like to evolve or replace the conventional mechanisms or from fossil fuel based machineries or equipments corresponding to these 3 or 4 types using EVs, electrical based tractors, autonomous drones where all are operated with electricity, and then utility vehicles for transportation and irrigation systems for watering and pumping cases. All are using electricity. Now, in the previous lecture, we would like to see the renewable energy source where this electricity which is supplied to this particular irrigation systems and farming systems and machineries used in farming system will be coming from or produced by solar PV, and that solar PV will be integrated to these electric vehicles, so that the electrical needs corresponding to all the all the machineries used in agricultural and farming systems will be overcome, and the operational cost will be reduced to increase the sustainability also. Okay. Why we are using IEVs in farming? The major thing is to avoid the greenhouse gas emissions. When if I using fossil fuel based machineries, whether it may be pumps, tractors, and all, transport vehicles, and so on, there will be a carbon dioxide emission and toxic gases emission. There will be greenhouse gas emissions will be available, so that air pollution will be increased and environmental effects will be more by using the fossil fuel based machineries. To replace that and avoid the reduction of greenhouse gas emissions, to provide sustainable environment, we move on to EV vehicles. And another one is lower fuel cost, because for a particular unit of energy, electrical energy, it costs around 3 rupees for a traditional electricity and electrical energy. Whereas if I integrate this EV vehicle with a renewable energy, that is a free of cost. Renewable energy is a renewable energy like solar PV. Then it is a free of cost, uh, that will be stored in a battery system, battery energy storage systems, and that will be used for running of all these EV based vehicles. And then advancements in technology, where integration of precision farmings in the case of drones and imaging systems, that will be used by using precision farming. And we are classifying each and every crop inside the crop by using imaging technology. Inside the crop, is there any weed is available? Where is the weed availability? How the weed can be classified? What are the types of crops available? Types of diseases available in the crop? Those are all comes under precision and smart farming techniques. For these technologies, we are integrating with IoT and precision farming, and for these cases, we use EVs as a farming techniques and farming machineries. And other one is governments are also subsidizing and promoting green farming practices by using EV vehicles. These are all various aspects why EVs are used in farming, and these are the examples which we already discussed. And electric tractors, John Deere is a company where they manufacture an electric vehicle based tractor, electric based tractor, and electric based drones for spraying pesticides, imaging, monitoring, and gathering the crop data based on health prediction of the paddy field. What is the growth of that particular paddy field for a particular time period? That is for 15 days. What is the growth? Whether the growth is sufficient or not? Is there any deficiency of minerals like nitrogen, potassium, any uh, urea, like that? Any deficiency of that soil has a deficiency of any minerals, that will be analyzed by using gathering of data corresponding to by using based on images in drones, electric drones. The popularly used drone is Agras. Agras is an agricultural drone, which is a DCA based drone, which is manufactured as a DCA drone, completely powered by electric energy. And another utility vehicles for transportation, like Ranger. Polaris Ranger is also one of the EV based vehicle for transporting goods and tools within the farm paddy fields, inside the paddy fields. And some solar powered and battery operated electric pumps are also there. Water pumps for lifting of water, and irrigation pumps for incorporation of or any integration of new technology with the existing scenario. The existing scenario is an agriculture. This for an existing agriculture, I would like to integrate EV. In the previous lecture, I would like to integrate PV, photovoltaic energy. Now it is electric vehicles are integrated. For an electric vehicle to be integrated onto agricultural, you need to mention sustainable goals, sustainable development goals. Those are increasing sustainability by reducing the carbon emission. Energy independence will be there because these electric vehicles are completely powered by electrical energy, and that electrical energy is supplied by solar PV. If I integrate solar PV with EV in an agricultural farming, then there is no cost incurred for operating these electric vehicles rather than a normal fossil fuel vehicles. And then by using a precision agriculture, combining EV with artificial intelligence, collecting the data from various sensors like soil moisture sensor and the imaging sensors, we can optimize the farming, and we increase the productivity of farming for and also give decisions or suggestions to the farmers which time or what type of pesticide has to be sprayed, and what is the growth of that particular farm. And in that cases, we are using precision agriculturals, and then by using EV case, we don't have any noise pollution, and there is no tail fume lamp, and so that there is no emission of gases corresponding to EV operated vehicles which are used in agriculture. These are the benefits for EV in agriculture, and these are the features of EV farming. Battery efficiency is one of the most important feature, and zero emission. This is another important feature of EV in farming. And coming to the smart features, we have because EV is again integrated to AI, artificial intelligence techniques or machine learning techniques, so that we can get the GPS navigation system, and we have a global positioning system, that is where the vehicle is available. We can have a real-time monitoring through different mobile applications or any web applications which was already developed and installed into that particular EV vehicle, and automated operations for repetitive tasks. For a repetitive task, for a particular human operations, they have to repetitively perform all the tasks in a human scenario, human labor or human scenarios, where if I use EV vehicle for a farming case, if I program a particular repetitive task for n number of times, then n number of time repetitive task will be automatically performed by using automatic vehicles also, by using autonomous vehicles. That is the smart feature which is available in EV farming. And to integrate EV farming, the EV into the agriculture, the major challenges are, as like in the previous case, solar PV to the agriculture. The major challenges are high initial costs because EV vehicles are more expensive. We need to have need to spend more cost as a capital amount when compared to the traditional vehicles, high initial cost, and limited charging infrastructure. If I want to move for a particular kilometer or a particular area in a crop field, if I have a 5 acres of land, for a 5 acres land, a single charging is not sufficient. That is a major disadvantage of a lack of EV charging stations inside the farm or near to the farm. If I have a battery fully charged, that will be having some range of operation, having some 250 kilometers range or 100 kilometers range. If that 100 kilometer range is completed within a 5 acres of land, I want to cut the crop, let us suppose that is the application of a particular EV vehicle, then in that case, near to that farm there is no EV charging stations availability, so that this is a major challenge where farmers are not aligned to this EV based vehicles which is used for farming technologies, because in rural areas, even though in tier 2 cities, EV charging stations are not available in Indian scenarios. Only some of the cities like tier 1 cities like Vijayawada, Vizag and Bangalore, like that, some of the EV charging stations and battery swapping stations are available. But in the rural scenarios where farming is available, those are not available. EV charging stations are not available. And battery limitations, shorter range, having even though we purchased a battery vehicle, EV vehicle with a high cost rather than a normal fuel vehicle, the battery cost is more and the range is very less. Okay, that range is very shorter for a normal sedan vehicles or SUV vehicles. In the case of battery limitations case, and it is completely depend on weather conditions. If the battery is overcharged, battery is heated up, then the discharging cycle is very fast, and then it will dissipate more heat. In some cases, the EV battery will burn out if the battery is completely exposed to overheating or overcharging case scenarios. That is a major disadvantage of battery. That's why the farmers won't rely or switch towards EV batteries, EV vehicles. And then awareness of farmers about EV technology. Most of the farmers are not skilled workers. They are illiterates and unskilled persons. So EV technologies are not aware of farmers. Lack of understanding with EV technology. That's why they would like to. They don't want to switch over to EV technology or EV vehicles for farming applications. Coming to integration of PV, agri PV with EV. We have EV vehicles which are available for farming applications, and all these EV machines, not only vehicle, there are different pumping systems and cooling systems, heating systems, all are based on electricity. That electricity needs has to be met by using a renewable energy, by combining agricultural PV systems along with EV, so that we have a sustainable agriculture, to have a energy system where it meets a sustainable goal, sustainable sustainable energy management. In that case, these are the major issues of integration integration challenges. The demand of PV and EV may not be matched in all the cases, and some infrastructure limitations, because the PV generator or PV or solar PVs are generating DC energy. Most of the EV vehicles are operated with some of the EV vehicles will operated with AC energy, AC motors and so on. In those cases, there are some infrastructure limitations, like if I have a 12 volt PV, 12 volt DC energy which is generated from the PV, but I want 100 watts of energy to operate a particular vehicle which is available as a EV for a farming application. In those situations, we need to step up or step down the voltage. Those are infrastructure limitations, and some economic constraints will be there for integrating agricultural PV with the EVs. And there are some technical issues, synchronization issues. One of the most challenging is power management and synchronization. Synchronization energy generation. Solar PV is generating energy, and the same solar PV energy has to be transformed to a EV needs. EV have a 12 volts battery, but in all the cases, solar PV cannot generate 12 volts battery. If I want to charge the vehicle, or if I want to charge the battery available in particular EV vehicle, it must be greater than the charging amps must be greater than the charging capacity of this particular EV battery, so that the solar PV cannot able to generate a consistent energy. There will be a problems of synchronization. In those cases, advanced power management softwares or advanced power management tools will be used by integrating AI and IoT into the energy generation and management of supply and demand. In those situations, we use AI and IoT based scenarios by identifying what is the need of charging vehicle, what should be the need of voltage or current charging amperes will be needed. Based on that, what is the generation which is available at that particular time, whether it is meeting to this particular need or not, then at what time it has to be charged, it should be shifted, load shift should be done, or shifting of scheduling of load can be done based on that scenarios by observing and integrating with AI and IoT technologies. And then intermittent energy supply. In solar based cases, we have an inconsistent availability of input based on the season and weathers. For a summer season, the solar energy will be very high, whereas some winter seasons or any rainy seasons or cloudy regions. In those situations, based on the weather and seasons, the solar energy will be very inconsistent in nature. Based on this inconsistent nature of solar energy, which is integrated to EV charging, but EV need a charging volts or charging amperes which is consistent enough. For that, there is a lag between solar energy and EV charging stations. That can be that is a major technical issue. And another one is need for energy storage systems, which is we have various battery storage systems available, but that battery storage systems are not stabilizing in supply because of this inconsistent availability of input supply and lack of standardization. There is no standard technologies for EV charging protocols with PV technologies. There are some compatibility issues with PV and EV that can be overcome. These are the various technical issues. And then coming to battery storage challenge, uh, these are the various battery storage challenges. We have only some of the technologies will be available, limited capacity will be available. Only 12 volts packs are available, 48 volt pack available, 24-volt pack will be available. Like a limited capacity of batteries will be available. But for a farming needs where EV should be integrated, the current battery technologies cannot be meet the farming needs. That is the limited capacity, based on the limited capacity of battery technologies, and the cost of energy storage system is very high. When compared to the total cost of the EV vehicle, if I have a EV tractor for a farming application, let it maybe cost of 10 lakhs. Among 10 lakhs, 8 lakhs will be of battery cost, and it has a guarantee or a lifespan of a maximum of 8 years or 7 years they give. After 7 years, you need to again replace the battery with 7 lakhs or 8 lakhs here, based on the charging and discharging cycles. That is the high cost for battery energy storage systems, and some environmental concerns for disposing and recycling of batteries, because they are completely of chemical processes, and it will add a carbon footprint to the environment if perfectly these are not perfectly disposed or recycled. That is the environmental issues and environmental concerns corresponding to battery storage systems. And coming to the charging infrastructures, we don't have any charging stations, lack of charging stations, which is nearer to the farms. If you use farm EV based vehicles in farming, that EV charging stations are not available in remote farms, where farmings are available in urban areas mostly. In urban areas, we don't have any charging stations to charge a particular vehicle. And then cost of deployment. Grid dependency, coming to the grid case, there is a difficulty of integrating PV with a charging solution, which is standalone system. Standalone system. This is off-grid form. Off-grid for an off-grid case. I have a solar energy. This solar energy has to be synchronized with the standalone charging station, and this charging station will be an off-grid station. It is not an on-grid. Even though in off-grid, there is no synchronization between solar and charging charging solutions. If it is an on-grid, then there will be a dynamic synchronization problem and dynamic change of voltage and frequency fluctuations will be available by integrating solar and this grid synchronizations. And compatibility with grid, we have different issues of power demand and supply mismatch. In the case of grid, I have a EV vehicle. Presently, we have a general grid scenarios. If I add a EV vehicle into the normal grid scenarios, in those situations, the high energy will be consumed by the EV vehicle because EV vehicle have high capacity like a 300 watt, 400 watt like that. It may not align with the power demand, may not align with the charging needs, and then instability of the grid. Feeding excess energy, if I integrate PV energy with the normal grid which is operated in a general scenario, there will be a fluctuation effects, and then there will be reliability issues while integrating with injecting excess energy which is supplied by PV to a grid. Where in the case of rural scenarios, grids are very weak weak enough. There is no voltage maintained. There are some fluctuations in voltages and fluctuations in frequencies also available in the case of rural grids. In those situations, we cannot able to integrate with the PV due to that fluctuations and reliability cases. And there is a bidirectional flow. If I want to integrate EV battery with the grid already existing grid, there will be a bidirectional flow between grid to vehicle and vehicle to grid technology. This is for nothing but grid to vehicle and vehicle to grid. There is bidirectional energy flow will be possible. In that bidirectional energy flow, there are major challenges, complex challenges will be available for a bidirectional flow of energy between grid to vehicle and vehicle to grid, like synchronization problems. And those are grid compatibilities and some financial gaps will be there. There is no, the payback period is very long. If I purchase a vehicle with higher initial cost, with high initial cost like 10 lakhs or 20 lakhs, the payback period of corresponding to this particular 20 lakhs is very long duration. So that most of the farmers won't rely or won't switch over to this EV based farming based on these ROI and high initial cost. And then financing gaps. There are some loans and subsidies. Subsidies are also provided by the government for a rural farmers. Even though these are very limited enough. The percentage of subsidies are very limited. The loans, the interest rates corresponding to these loans are very high in the case of financial scenarios. And the awareness of farmers, the knowledge gaps. Many farmers don't have knowledge of operating PV or operating EV. Operating PV, nothing but maintaining maximum power point tracking and energy storage systems. In the case of energy storage systems in EV, we have to maintain SOC, ROL, and SOH need to be maintained. Those cannot be maintained by the unskilled and unfamiliar farmers. That is the major disadvantage of farmers to have a switch over from conventional fuel-based vehicles to electric vehicles. And then resistance to change. to the farmers for awareness of various technologies, technology advancements in the case of EV and PV based farming technologies. Government also initiated training programs. And next one is land usage conflicts. There are some conflicts of land usage already discussed in the morning session. For dual purposes, crop and PV installation purposes of uh, agricultural land, there are some regulatory issues will be there for land usage of dual purposes. The same PV panel which is used for cultivation and solar panel generation. That is difficult in Indian scenario. In those cases, they have some challenges of regulatory bodies. In those situations, they hesitate to switch over to these particular technologies. That is PV to crops. And then optimal placement. There are poorly designed layouts. Always the PV panels are with the fixed sizes. Those PV panels fixed sizes, the crop yields and for a particular agri PV, the design is very poor. Uneven designs will be there. In those situations, they want to optimize panel placements and all. And next case is dual usage of agriculture, that is agrivoltaics. In those agrivoltaic systems, there are some specific regions. Uh, some of the specific regions, like in the morning session, I discussed Japan, Germany. In those situations only, these agrivoltaic systems will be used. And in Indian scenarios, there are some issues corresponding to usage of these agrivoltaic systems. And productivity issues. One is shading effects, irrigation problems, and climatic suitabilities. All climates cannot be suitable for agri-PV systems based on dependence on crop, depending on solar intensity and weather conditions. Based on these weather conditions and the solar intensity of a particular region or a demography, you need to include agri-PV at that particular situations for a particular crop type only. Some of the crops need solar always, not solar, that is sun always. In those situations, we cannot able to install agri PV in a crop for that particular crop types. And there is a effects of shading. Some of the crops for growth and yields of that particular crop, adequate sunlight will be needed. If I install a particular PV panel above the crops where they need adequate amount of sunlight, then they don't have impact on growth and yield of a particular crop. That is the various shading effects will be available. Due to that shading and less sunlight, inadequate sunlight, the crop growth will be affected. And some mitigation problems like traditional and PV systems has to be integrated, incorporating these PV systems with the existing traditional system. There are some irrigation problems. To address these challenges,
Some shading effect, sir, can you, the morning is also on software, sir. Morning session is also on software, sir. So, region specific some data is available.
okay.
For example, you go to tomato or tomato like that.
I have a crop based data and I have a region specific data will be available.
With help of this, can you able to find the tilting angle, placing of PV cells or shading the PV panel? You have to avoid the effects of the.
Yes, sir.
Is it possible to do the pendulum analysis by using the software?
That machine learning techniques which I shown in the morning session, if the data is available for a particular crop type, for that particular crop type and for the region, which is solar irradiation is also there. In that cases, partial shading effects will be taken into consideration, and we can able to identify what much the tree canopy should be done, and that will be given to a motor, and solar panel has to be fitted by using machine learning methodologies. But the data set has to be in such a way that all the features will be available, like a particular crop in different demography, solar irradiations will be there, temperature and irradiation of the solar, and for that particular solar, partial shading effects will be there, and kill timings can be identified. Based on that, kill timing can be identified. Okay. There is a software, sir, open source software. I will discuss with that software today and next slides. There are various software tools will be there for a particular demography, like Bomber. Bomber is one of the softwares, open source tool. In that Bomber, if I given a latitude and longitude corresponding to a particular location, let us suppose I want to install a rooftop solar in your college itself. I given a latitude and longitude details to that particular open source software, Bomber software, and another one system advisor tool, and advisor one software is there. In those situations, all the PV data will be available corresponding to that solar irradiations will be available. If I want to integrate EV for a particular value of EV, if I want to integrate EV to that particular PV, how the supply and demand can be forecasted. There will be a socio-economic and technical aspects will also be discussed in that particular report will be generated in the software. I will show the software also. Based on that software, we can analyze economically and technically also. Techno-economical analysis can be done by using that open source software for any area, for any crop. In those situations, we use open source tools and identify which area, what is the crop type. For a particular crop type, you need to select an area, and in that case, whether PV is possible or not, any renewable energy, whether it may be a PV, it may be a wind, it may be any other renewable energy source. If I want to integrate that renewable energy source with my crop corresponding to a particular demography, that will be done. And to get rid of those challenges, these are various innovative technologies which are developed, and policies will be derived for integration of renewable energy with EV. Governments already given some tax credits, zero interest loans, and some grants like schemes will be there. There will be some subsidies will be given for integration of renewable energy along with EV. Okay, this is the initiative taken by the governments where they push most of the consumers from conventional fuel vehicles to renewable energy based and electrical vehicle based systems. And some regulations will be streamlined. For a rural case, mostly the agricultural lands will be available in rural scenarios, but the EV charging infrastructure is not available in a rural scenario. In those situations, the regulation bodies will take necessary action to fast track approvals corresponding to EV charging stations to rural cases also. And then some carbon credits. By disposing the batteries, there will be some carbon deposits, or carbon deposits will be available in the land. If we perfectly dispose or recycle a particular EV based energy storage system, then for a sustainable recycling, they will provide incentives, and carbon credits will be given to farms where they adopt green EV with EV systems, or cleaner technologies agricultural, PV, along with EV. These are the three technologies. And they also have smart grid technologies like vehicle to grid technology and grid to vehicle technology, which is a bidirectional charging between vehicle and the grid and vehicle. Bidirectional energy flow can be coming, and some load balancing techniques to manage energy flow between PV. PV is the primary source of energy. By integrating PV with EV, what is the generation capacity? For this particular generation capacity, what is the demand at that particular time? That will be identified by running a forecasting algorithm or load forecast algorithm and optimize the electricity distribution between different time scenarios like peak hours or off-peak hours in those situations. And also we can run a demand response for a different peak time and off-peak time periods. We run a demand response curves, and demand response situations will be run by integrating solar and EV. And hybrid renewable energy sources, not only relying on only one solar source, we would like to integrate or combination of different renewable energy sources like solar, wind and biomass, combining it together. We will to meet a power demand, like demand is more, the power supply corresponding to a particular solar panel, only one solar panel is available, particular solar panel is very less, then we will to integrate with other renewable energy source rather than go for a fuel cell based vehicle. We will integrate with other renewable energy source to increase the power supply and meet the energy demand at that particular time scenarios. And then diversification based on different combinations. In some of the cases,
I have a question. On the small scale, wind turbines are biomass and solar panels ready available because farmers, farmers trees are asking.
Readily available.
Ready available.
For a 1 kilowatt, 2 kilowatt, 3 kilowatt like that, readily available. Biomass systems are available. Wind turbines like Archimedes wind turbine I already given example in the morning session. That is already readily available. Companies are there who will manufacture for your custom needs. If you want to integrate 2 or 3 renewable energy sources, they will provide a survey on your home needs and agricultural needs, and based on complete survey, they will customize the solution by integrating 2 or more renewable energy sources like solar, inverter, or then wind with biomass or a EV pattern. Like that, they integrate all of them together, more renewable energy sources together, and even solution. Fuel cell also based on presently most of the cases they use hydrogen based fuel cells. In the previous scenarios, hydrogen is very less available hydrogen in there. Now they are producing hydrogen abundantly, so that they are researching about hydrogen based batteries, energy storage systems, and hydrogen based fuel cells also they are using. And in some cases they also use methane gas as a primary source of energy for a fuel cell, because methane gas is produced by using a cow dung itself directly. The- no, there is no. No, already fuel cells based on methane gas is also available, but it is not available in the market. Research is available. Fuel cell based on methane gas. That is also fine. Okay, and there is a high fuel-based cars are also available. Recently, hydrogen train is also available. Recently launched hydrogen train, hydrogen vehicle. Train is also launched
research. Because water is abundant, by processing the water, they completely convert the water into hydrogen gas, and then that hydrogen gas is taken as a fuel for a fuel cell and store the energy, and that stored energy in DC form will be utilized for different applications, as like your normal battery, lithium ion battery. And some of the cases in the research case, most of the projects I see, they inbuilt propose a digester, artificial digestive system they proposed, and based on that artificial digestive system, they itself they produce methane gas directly. Artificial digester means they push all the enzymes as like a cow stomach, all the enzymes and grass and wastage inside a home, that is vegetable waste and all the wastes will be poured into that particular artificial digester, and it will be fermented. That fermented process will be combined, giving a methane gas. That methane gas will be transferred to fuel cell. That is also possible. Projects are there in DST based projects also proposed. They propose. Okay. You have different applications and different problems also there, and the industry based problems will also be there. I will show you where the problems are available. For a particular researcher, how to select a particular problem, which is industry specific. How to select a particular problem. I will show, there is one website called, website will be there. All the industries will post their situations and their problems and invite solutions to that particular problems. If you write a proposal corresponding to that particular problem or meeting that particular problem with your technology, they will accept your proposal and give funding to that particular proposal. Most of the industries will be available in that single platform. I will show you ahead. And there are various battery storage systems. There are solid state batteries rather than normal lithium ion batteries. We have lithium iron phosphate batteries are there. Solid state batteries are there to increase the energy density. That is, with higher energy density, we have more energy will be stored into that particular solid state batteries, and which will have a longer lifespan rather than discharging or recycling with a shorter lifespan. And there is a secondary batteries will also be available in EV case. In the EV case, the heart of the EV vehicle is a battery. If battery is gone, the complete vehicle won't have any value. Battery is only the value. Okay. That's why they use secondary battery vehicle. Battery is also proposes secondary life or second life EV batteries. Two second life batteries will be there. In the case of EVs, they will increase the life of the battery in that case. Thermal energy storages, they use heat energy as a store, like water energy. In the previous scenarios, water pumping will be done and water will be stored. Here, heat energy will be stored rather than solar, rather than electrical energy. They store heat energy for drying purposes of crops. And these are the financial models, affordable finance models, like leasing some programs. Leasing means as like a land leasing. Some of the PV panels can also be PV panels, which is integrated with EVs, can also be leased. This is called as energy market. Energy market will be there. I have a installed 10 kilowatt installed solar panel will be available in my home. 10 kilowatt is available, but my need is 1 kilowatt only. Rather than supplying or injecting the additional surplus power which is generated by the solar panel into a transmitting the energy, okay, or overhead lines. Whereas in the case of energy markets, there are two peers. Peer 1 has one solar panel having 10 kilowatt, and he has some demand, energy demand. And peer 2 has some wind farm will be there. That is a simple nanogrid. This is a simple nanogrid, and that is another simple nanogrid. Those two are called as peer and peer 1. Peer 1 and peer 2 are node 1 and node 2. Between these two nodes only, we need to transfer. If I want energy to be utilized, if my energy demand is more than my generation of solar PV, rather than taking energy from the grid, I am taking energy which is readily available with the neighboring solar panel or neighboring renewable energy source. They will directly sell the energy to me and I utilize that energy. Whenever I have surplus energy, I sell the energy and they utilize. That is peer-to-peer marketing. Energy trading will be done based on the dynamic pricing will be done. Dynamic pricing is the scenario where presently we don't have any dynamic pricing scenarios. Energy tariffs are always fixed. Same time. More power. If both are excess, they give surplus power to the grids. Then they have income generation at that case. That in the previous scenario, rather than converting or rather than utilizing grid energy, bearing all the losses from grid to generating station to your utility home, I can able to transfer that energy, excess energy, which is neighboring to mine, so that the distance is very less and there is no losses available. So that a qualitative power will be available corresponding to that particular energy. That is a future. In this situation,
one kind of
already it was there, sir. Peer-to-peer energy trading and marketing will be there by using blockchain technology. Blockchain technology is popularly known for Bitcoin transfer. Bitcoin transfer, have you heard about Bitcoin transfer? For a Bitcoin transfer, blockchain technology is used. That is a machine learning technique, blockchain technology. In blockchain technology, there are contracts between two parties, party 1 and party 2. We has a contract which was transparent contracts between these two parties only. There is no need of any transco people or Gentoo people involving into this energy market. He has energy production and consumption. He is also having energy production and consumption. Those scenarios called as prosumers, which will consume energy is consumers, which will produce energy is producers. Then both are is there. Then those are prosumers. Prosumer 1, prosumer 2. Prosumer 1, prosumer 2. They have different contracts. That contracts will be signed contracts that will be available in blockchain. That is a centralized system. There are 10 number of peers. That 10 number of peers will be centrally communicated with a centralized server. That centralized server will be operated with a blockchain technology, and that centralized server will decide where the energy need is available, where the need, if I have energy need, I want a 1 kilowatt of energy at this particular time, where the 1 kilowatt surplus energy will be available. And I have already given a contract to the central server system such that I want to buy that energy need of 1 kilowatt with a pricing of 6 rupees per unit. Like that, I mention a contract. Then the central server system will identify where the surplus power is available for that particular rate. Then it will be transferred. That is the contract. among 10 rupees, they have to, I take a scenario of only two. There are 10 members. Lines will be there. Because each and every prosumer is connected to the grid through a net matrix. They can inject the power, they can utilize the power. Okay. Now, prosumer A is connected to the grid, prosumer B is connected to the grid. They can utilize the power from grid or they can inject the power to the grid. The central server is a mediator between grid and these two prosumers, such that whether he want energy from the grid or he want energy from a nearest station or nearest prosumer who has surplus energy with some price. Then dynamic pricing will be there.
Who will decide that price?
That price will be decided by the prosumer. నేను అమ్మేవాడిని నేను డిసైడ్ చేస్తాను. If it is peak load or peak hour, the price will be varied. If it is off peak, the price will be various. Consumer or a prosumer? Consumer or a producer? That like okay. Frankly, general OH lines will be there now. All are connected to grid. They will inject power and consume power. Complete transmission. Rather than moving towards generating station, which is far away, and burdening all the transmission losses, there is no losses. If I have a microgrid in this, having 10 number of nanogrids, then among these nanogrids itself, energy trading and energy transfer will be done. This was already done, practically implemented in IIT Gandhinagar. They have taken 3 rooms side by side. One is solar, another is battery, another is wind which is connected, and the loads water tanking, pumping systems, ACs, and fan, lights. They have consumption and energy transfer also. By using Raspberry Pi simple technology, they write a contracts in Python language, Raspberry Pi. They have trading. Simple trading can be done. That is practically implemented in IIT Gandhinagar. Electrical department. Okay. One PhD scholar is there, Sachin. Sachin is one PhD scholar. That there he done the complete scenario in practical cases. In future, that is the market. In future, the India will go to that energy trading and dynamic pricing also done in Indian scenarios. Okay. Only the case is, if you want to inject the energy to a grid, you need to synchronize with the grid frequency and you need to maintain the power factor for a quality to power. Like that, you need to take care of all the measures, security measures. Then only you can able to transfer or trade can be done between any two parties. That is our responsibility. That is leasing. Another one is community solars. Forming a group of people or a gated community, rather than installing a solar panel on each and every building, each and every home. A group of people combinedly together and install a big solar farm. Then they meet the energy demand of that particular solar panel. Supply will be there, demand will be a community of homes, community of different homes. Like that, they use lamp dimming is problem. So lamp dimming అంటే ఇదా ఆగిపోతుందా Okay, that is another case. Sharing of costs here, the energy is sharing by leasing programs. Here, the cost is sharing rather than burdening of individual farmer. Group of farmers or group of people will be combinedly, and they will invest very low value and produce a solar farm by using different energy cases. And then microfinance. There are some loans will be available for very less interest for rural and agricultural scenarios by the government. And how IoT and AI will be integrated. IoT and AI in energy management, I have to manage the energy because I generate the energy I generate the energy by using PV and I utilize the energy or store the energy by using EV. Between PV and EV, there must be an optimized energy transfer and management of energy to meet the supply and demand. For that case, some AI-driven energy management tools will be there for forecasting of solar energy generation and forecasting of load demand corresponding to EV. If the solar generation forecast and the EV demand load forecast is matched together, then those are synchronized together. Like that, they need solar generation forecasting can be done, crop demand energy forecasting will be done for different planning of PV EV integrations. And we also integrate IoT to monitor and perform various systems like SOC, state of charge, state of health, and remaining useful life of a battery in EV case, RUL. And in case of PV, what is the maximum power, at what time it will be available, at what month it is available, like that. We can able to get all the things. And we need to alert the maintenance issues also to the consumer. And then finally, precision farming. Precision farming is based on sensors, utilizing data from sensors. Based on the sensor data, we need to have a eye on crop. What are the requirements of a crop to yield better or to produce better output, productivity, better productivity. That is the next case. Next one is improved crop compatibility by using dynamic panel adjustments, tilt angle adjustment, and different adjustable angles. Based on dynamic panel adjustments, we improve the energy production and some automatic shading solutions. Now, for sensitive plants, we are using automatic shading solutions will be there. These are all research opportunities. Some of them are already available, but some of them are not available till today. And then dual usage of lands. This was already covered. Combining solar and crop like different herbs. Dual usage and regional customization based on the regions also. We need to aware of climate specific PV designs like some coatings will be done and some based on some regions and for PV panels for hot climates the efficiency will be maintained and for a agricultural case EVs has to be customly devised for a suitable agricultural needs for different terrains. Some of the cases, the agricultural land will be a hilly station. In those situations, EV will be having more torque. The motor which is available in the EV will be more torque because it has to be have a more load while climbing a hill. Whereas in some cases, that is a completely in the downstream. In that situation, so there is no burden on the EV motor. Those are the various terrains, various rural terrains. Based on that, customized EV will be tailored for agricultural needs, and then charging infrastructures also. For an off-grid case, we need local charging stations charging, DC charging, AC charging, wireless charging. There are so many cases in EV charging scenarios. These fast charging techniques are not available in Indian scenarios. We always use normal charging stations, uh, which are slow charging, and in a home scenario and a commercial scenario, those are available in Tier 1 cities. All these three, all these two, wireless charging is not also not available because roads are charging pads or roads are implemented in such a way that while moving electric vehicle itself, it will charge. That much sophisticated roads are not available in India. And for a off-grid solution, I have a localized microgrids which will integrate with PV and EV, and some standalone systems will be available for off-grid case. And these are various innovations: a green PV plus EV, fully integrated system, which are solar power drones and for crop monitoring. This is the best example. The power corresponding to the drone will be powered by solar. Solar panel, the frame will be of solar panel. I have four motors. Frame will be attached with the solar panel. Solar strips will be attached to the frame, and solar power will be generated from the solar strips, and that will be supplied by the motors. And motors will run, and motors and the camera will run, and it will monitor the crop by taking the photos and processing a machine learning algorithm corresponding to that particular disease and all, and given decisions to that particular customer or a farmer. In that situation, this is the complete solution by integrating agritech, PV, EV. Okay. Uh, Agri PV up to this is available. These models are available, sir. With solar, practically is also available in some cities. Using solar itself, they operate drones, agricultural drones, because agricultural drones are for a pesticide spraying. This is not possible because for a pesticide spraying, the drone capacity is more. It has to lift 10 liters of tank or 20 liters of tank. The drone capacity is very more, and if I add a solar panel, it is an additional budget. For monitoring of crop, means a simple camera is enough for us. A simple camera, that is a FPV drone is fine. A small drone, a slam drone is fine to capture the photo of an individual paddy field or a crop. In those situations, solar panels. If for a higher drone, if I want a solar, and that is not enough power supply to the motor because it has to lift 10 liters or 20 liters of tank. But here, all the motors will be of 7 volt, 10 volt, 12 volt, maximum of 12 volt for crop monitoring. And the flight time will be of half an hour or 1 hour only. The flight time is also very less, and altitude also very less in monitoring drones. Successful, we don't know. No student is interested in those technologies. AP, not only AP, sir. All the state governments are ready with imbibing technology-based advancements into the young minds. But no student is ready to take the challenge. They want the CPC. That CPC won't be done in these scenarios. the end of the day, they want CPC, 15 lakh per annum, 10, 20 lakh per annum. That is the figures they want. But for this, those are not possible. For monitoring drones, this was the complete solution is available, sir. And then blockchain. Blockchain is also the next trending technology that is also readily available in implementation stage for energy trading and to sell and uh, sell excess energy and consume energy from different consumers. And then next generation solar panels, that is bifacial, transparent, like that. There are different solar panels will be there. And these are the future outlooks. Solar PV efficiency improvements. This is the current state. Up to it has 18 to 20% only the efficiency. Commercial panels, the average efficiency for a commercial panels, and they want to increase the capacity beyond the 30%. Okay, by using the materials called, presently they are using the material called polycrystalline and monocrystalline. They want to use these materials, perovskite and tandem cells. By using these tandem cells, they want to increase the efficiency beyond 30%. Okay. In battery storage also, they want to integrate some alloy-based things rather than only the lithium ions. Already the research was started and some of the technologies are already released into the market. Lithium iron phosphate, lithium phosphate, lithium ferrite, like that, different chemicals mixed. Based on the mixing of various chemicals with any one chemical as fixed item, that is lithium is fixed. Then the battery energy density will be increased and the life of the battery will be increased. And the size of the battery is also decreased. Have you ever observed the 3.7 volt battery in a mobile? How much its size? Will it change in size? Less weight. The same 3.7 volts lithium ion battery has, both are rechargeable only, but that is not a lithium ion, that is lithium phosphate, lithium ferrite. Based on composition of chemical, then they reduce the size, they increase the energy density up to 6000 milliampere hour, 18 ampere hours, like that. They will increase the energy density. Energy management systems. In future, they want to integrate rather than lithium ion only. They want solid state batteries, sodium ion, and some second life of the batteries. These are the future scenarios. By combining various chemicals, they want to increase the energy density. Higher energy density and the longer life. For EV case, they experimented for second life batteries. The same battery, they want to recycle and second life battery will be given to the EV. And some smarter energy management systems will be there by involving AI and machine learning into the demand and supply management systems by using different data. And some autonomous agricultural EVs will be there. If you program, if you given a terraceous like a radius, if I want to spray a particular land, I have a 1 acre land. Among 1 acre land, I given points. This is point A, point B, point C, point D. Then your electric vehicle will move according to that particular points, and map will be loaded into that particular electric vehicle. Not only in in various traffic signals and in highway-based signals, they use this technology. In highway, they have a survey corresponding to a drone. They given a particular map from Vijayawada to Vizag. They given a map. The drone will move towards that map. They move towards that map and taken a pothole photos. Whether pothole is available, how many potholes available in this particular region, where it is available, with a particular GPS location will be sent to a higher authorities. Based on that, they will maintain. They will call for a tender and a maintenance of highways will be done in next step like that. That is already implemented. And recently we with NIT AP we discussed with DGP Andhra Pradesh where they want to involve this autonomous drones in traffic light signals and accident predictions. That is also done in near future. Okay. They want that project. DGP. Yes. Police station. Accident predictions and corresponding accident predictions will be intimated to nearest hospital or any service, ambulance like that. And then traffic also. We already have a Google. Google will say, Google Maps will say, this is the more traffic way. Like that, they will want. They want that. By combining agri PV and EV charging, we have some ultra fast chargings, solar powered EV chargings, like a solar shed will be available, and there will be a charging station which is powered by solar directly. Based on that solar power charging stations will be there, ultra fast charging stations will be available, and there are some integrated renewable energy sources. Not only solar, there are more number of renewable energy sources will be integrated to EV charging station. And these are the costs for next 5 to 10 years. What are the different costs of both solar panels and EVs? It will decline due to economics and technology improvements. They will reduce the cost. And rural economy boost. And they will supply in the rural areas also. They want to integrate electric vehicles and charging stations will be produced at the rural case also. And EV adaptation in agriculture by 2030, they want to completely adopt agricultural EVs with electric. This is the scenario. And smart cities and sustainable infrastructures by using agri PV with other sectors. And these are various technology improvements for complex power management, energy storage limitations. These are the technical challenges which we already discussed. Just I given a summary of them. Regulatory policies all will be given. Next, where the challenges will be there. If I want to work on a industry problem, then where to search for its challenges or any problem statements. There is a website called Manthan. the website. Manthan. In this, they given different segments and their problem statements. See, they given different problem statements based on industry needs. Like this. See, if I have selected any AI, ML, NLP, search. There is a internship call, and all will be uploaded here. For every problem statement, they will upload for different segments. For a government sectors, if I want government sectors only, let me have a login. I want to open. Let me sign in the portal. If I signed in, then only it will show problem statements corresponding to cases. These are all the various problem statements. If I search for solar, let us suppose for solar it is not available. EV. Better you see this rather than that will be relocated to this only. Problem statements. This is the problem statements. See, I explain anyone. See, organization is Godrej Appliances. Godrej Appliances is the organization. They have a problem statement title is innovating for sustainability, driving smart resource conservation, energy and water in home appliances, refrigerators, air conditioners, washing machines, and desert air coolers. They want a hardware project, and for this problem statement, they given all the description. What are the need they want? This is the problem statement title, and description will be the same they given, but The organization is Godrej company. Godrej company has this problem, and if you propose a solution, already how many members are submitted the solution? 219 members already submitted the solution. Okay. Among that, they pick anyone. Another C. AICTE student, these are the complete programs. Okay. So, see, Department of Science and Technology, development of a portable device, non-contact device for measurement of eye pressure in glaucoma patients for usage at home. This is another problem. This is another problem statement that till now they have 138 submissions. Like that, you have different problems. If I want to search for a scholar, see, Department of Science and Technology, development of a non-electrical device for tracking the movement of the sun, for movement of the solar panels, increasing their efficiency. This is one of the problems. Clear? If your solution is up to the mark, then they release fund. They select anyone and among all the submissions and release fund corresponding to that particular project, and complete project will be awarded. Okay, hardware has to be proposed. And another one is Ministry of Power also having problem solution. You can take directly these problem statements as your research problems and directly implement those solutions in your research and produce papers also. Hardware and papers also. You can get patents also. Because it is problem statement of an industry, it was not available. You can get a patent if you have a solution. Likewise, you get to know what are the different problems available and how it will be impacting the society. These are the websites. Smart India Hackathon is one website. Every year they conduct a hackathon corresponding to this. And from Manthan also you got some of the problem statements. And some opportunities will also be getting from Manthan. And another case I already given, Former software. This is the software where all the settings will be done. I will show you. the research paper which was published on Commerce Software itself. Adim problem.
కమెంట్ అవసరం బయటకి ఆన్ చేస్తారు ఇంకా కింద చేస్తాం కిచెన్ కానీ కింద చేస్తాం
చార్జర్ పెట్టేసాయి చార్జర్ ల్యాప్టాప్ చార్జర్
Okay.
ఆఫ్ చేసేసాను. Dear participants, take a break of for 10 minutes, then we will meet. Sir, okay now? Sir, start the session, sir.
As discussed in the previous phase, we have different open source software tools for analysis of solar PV systems and uh, EV integrations to various scenarios. Now, for a solar PV system with the shading analysis and energy yield prediction, we have a open solar, which is a customizable dual use application for agri PV based systems. This is a open source software which is free and accessible for various farmers. You can able to get a complete modeling corresponding to this open source by using open solar software. You can completely model agri PV system based on the crop, based on the solar energy which is installed on top of the crop, where it may be a land based or maybe a vertical based like that. Simulation done studies will be done by using this. Another one is system advisor model. In this, this was developed by NREL, which will simulate PV system performance and account for agricultural land shading for designing agri PV systems for specific farm requirements. So we design system simulation studies can be done by using system advisor model. There is another software tool. Next, third open source tool is Farm OS. This is also an open source tool for farm management. How to track a crop, livestock, or a solar energy usage, and what are the various IoT devices integrated to that particular farm, and real-time farm monitoring can be done by using Farm OS. Okay, this will be customizable, scalable for any farm of any size. Next one is a Python-based library will be there. PVLib is a Python-based library for modeling solar PV systems, for analyzing simulation performance, for various weather conditions and shading analysis will be done by using PVLib Python. PVLib Python is another software tool. And another open energy monitor. In open energy monitor also we can monitor PV energy generation, consumption and storage, including any EV battery. And real-time dashboard can be done for a farm energy management by using this open energy monitor. This is for integration of PV for an on-site power use. We are using this open source tool. And another one is QGIS. QGIS is for a particular geographical information or a particular geographical system for a topography. I want to install a particular solar agri PV at a longitude and latitude. At that scenarios, what should be the solar irradiation corresponding to that particular land topology, and what are the optimal PV panel placements, where to place the PV panel, at what longitude and latitude it will be placed, and what is the discussing with all the softwares. I will show you one software, Homer. There is also an open source tool which can integrate solar, EV, and renewable energy, all the renewable energy cases. It has the developer is NREL itself. NREL people is developed this Homer energy, and it has completely 193 countries data will be available in this Homer software. And in this case, software is available, education and training is done by using these softwares. Consultation is also done for advising on microgrid design, project development and markets, and some market assessment is also done for different suppliers and partners in this software itself, so that this is very much useful for socio-economic design of any microgrid. This is how the software will look like. If I have a different generating station, utility grid.
Sir, I have a question. Suppose you want to give the training to the students for the common for doing the projects, so how to conduct
Training is self-paced videos. In the Homer, no. I will train. If you then these are the generating stations, generating setup, utility grid, wind farm and fly wheel. I am taking two renewable energy sources, and I have another solar, battery, and a hydro is also there. All the I included conventional resources, renewable resources, neighboring grid connections, storage systems, and some load management is also done. Electric grid or electric load, deferrable load, converters between AC to DC and DC to AC, and some load management system will be done. All will be connected together, and you can done the cost analysis, least cost solution corresponding to this particular scenario, and what is the how much distributed power will be done in this case. That is also done by using a Homer software. This is how this is the complete design cycle of a microgrid. Collect the data corresponding to a microgrid, analyze this data and evaluate and improve the data. This is the design cycle followed by Homer.
can you consider the college
You can consider. That is completely a load, sir. That is not a microgrid. If you have a rooftop solar, and connecting to a grid, which is rooftop solar is already connected to a grid, then it is called as a microgrid. There's two softwares will be available, sir. One is Homer, another one is SAT, System Advisory Framework. Those are two are open source itself. You can analyze anything. I will show you the example also for this. Here is one example which was already done by Sandeep sir. A case study in the identification of best combination of energy resources for hybrid power generation in rural communities through techno-economic assessment. Actually, in this, they take this was not downloaded. Maybe this was downloaded. By using Homer software itself, they design like this. These are the various cases. I have a diesel generator directly supplying to a primary load. That is first case. Second case is I have a diesel PV battery and a primary load. This primary load is of either DC or AC. If I have a AC, then directly diesel generator can be supplied. If it is a DC, primary load is a DC, I have battery and PV system. And third case, I have both diesel, hydro, BWS, XLR, that is some other source, and battery. Now, a primary load is flooding from AC. This DC is again converted to AC. This DC bus is connected to DC sources. AC bus is connected to AC sources. And whenever is needed, this DC is converted to AC and AC is converted to DC by using a converter. That is third case. And fourth case, we are adding a more number of loads. Rather than a primary load, there is a dump load along with a thermal load also. Okay, like that for various scenarios, there is the complete scenario. The fifth case and sixth case has a complete scenario where generator is there, lander is there, and then battery, deformable load, primary load, electrolyzer, and then hydrogen tank. From the hydrogen tank, it will be connected to a generator as a fuel, and finally these will be operated. For all these scenarios, they want techno-economical analysis corresponding to those scenarios by using Homer software. They produce results like this, simulation results, state of charge of a particular month, power corresponding to a battery when DC primary load is available and a PV power is available. This is the PV power, this is battery state of charge, and this is DC primary load. Like this, they given different scenarios, and all these scenarios will be modeled and the report will be generated like this. This is the complete report for a generation, battery, conventional energy sources, initial capital cost, and the total cost, and what are the COEs, and then what is the diesel energy generation hours. Based on that, here they are given all four will be on, any one will be off. Then what should be the cost affecting? This report will be generated. These are the complete optimization results based on configuration sorted by total net present cost. Based on this scenario, all will be connected together. Okay. This techno-economical analysis, technology assessment will be done, and also economic analysis will also be done by using this Homer software. And then we can also done sensitivity analysis by using different graphs. There is another report for sensitivity analysis. There is the complete average load availability. And physically that will be modeled by using a Homer software. Let me show you the result of a homework. Based on the technical assessments, we can able to design physically. First you simulate by using homework. After that, based on the technical assessment, you can design physically. This is how the homework software will work. There is another tool, that is System Advisor tool. I will take a simple example. Like this, it will be there. This is completely software, sir. System Advisor tool is another software. You need to add a latitude, longitude value corresponding to a particular location. I select any one location here, already added. Any one location I selected. And for that, if I want to view data, this is the hourly data corresponding to that. And if I want daily data, it will produce a daily data corresponding to the solar only, beam irradiation. And if I want wind direction data, that is also done. If I want pressure data or any irradiance, plane of irradiance data, that is also done. Like the daily data, monthly data, heat maps will be generated, and corresponding to each and every month, the profile will be generated.
I have a doubt. What is the need of what is the purpose of heat graph, sir?
What is the heat graph? Heat graph. Based on the colors, this heat map, blue color is normal.
Okay.
Most dangerous is red.
So by identifying the colors, you can easily analyze the data.
Analyze the data. This is the complete profile of a different months, and corresponding statistics will be produced like this. What is the mean? What is the variant and all? And some duration curves will be there, and scatter plots will be available.
Sir, is it freely available software or
Freely available.
freely available?
For each and every case, you can identify. For every, if you want your own data, you given your latitude and longitude values. For your own scenario, it will be giving. You can design location and resource. You need to first identify. After that, you need to module. Which module you want, solar panel and like that. Inverter design, system design, shading and layout design, like that. For each and every case, you can design and simulate it. After simulating it, you can produce the complete report. Based on that complete report, for a particular latitude and longitude, you can produce that.
If you use these two data, that is the latitude and your data, can you be able to the solar tracking you get exact data?
Exactly.
It is like automatically.
Automatically.
So solar and generator, everything.
Everything. You need to design, sir. What are the components you want? But the historical environmental solar irradiance data will be given. for a particular location, if I given this place, Vadlamudi as longitude and latitude, for this place, what is the solar irradiation availability for January month, February month, that historical data will be given.
So
if you want to
in the
develop,
previous those angles are available. So if you do that data, automatically it will come. Okay, in the back in the reason that is
historical data.
historical data.
Based on that historical data, you can predict future.
So
by using a machine learning algorithm.
ML by using ML, you can predict the around. So that data resulting data is used for our purpose.
Research purpose.
The electrical means connection and disconnection. Okay, actual connection disconnection. Actually, you need the infrastructure, which are the consumers as well as distribution operator. You need communication. So by using the communication, you can get the actual data. Okay. So suppose we want to generate, for example, I need to travel from college to my house. Okay. So these are about 20 kilometers are there. We need to study practically with these electrical vehicles. So the what amount of power is required to charge the electrical vehicle. For 30 days you take greater than 30 days. So are you able to simulate the kind of situations here?
That kind of data can also be simulated, and the drive cycles can also be given. Well, I already given last time. I already imposed one software, fast sim. In that, your own drive cycles can be given and simulated. Fast sim is another software for electric vehicles. Like this, the report will be generated. For each and every case, I randomly selected one data. For that particular data, they given complete analysis technically and economically. What is the cost, lot. This is the complete summary.
I think we discussed the PV system now, sir. This side we are observing location and location resources, modeling, what system design and shading and layout. So shading and layout.
You need to design what type of shading you got, how much module width will be there, module length will be there, module area, aspect ratio of the shading. Based on that, this will be modified.
So I think this is related to agri PV systems. Agri PV system also you can design. Normal
PV partial shading connections also you can design.
Okay.
In normal PV also, if any building shade will be imposed on a PV, that is a partial shading. It won't generate data. It won't generate energy there. A very less amount of energy will be generated at that particular case. That scenarios also you can simulate.
Incentives, something is there. Installation cost, operating cost. I think all these are related to power generation. Bi-direction, suppose we have EV, bi-directional charges are available.
Yes, sir.
That kind of, I think that is also possible.
Possible, sir. You can, in system design, you can add what are the number of inverters will be there, what is the DC to AC ratio, what is the DC capacity. The DC capacity is your EV battery. But load, DC load as a EV battery load.
Total DC means normal load.
Normal loads.
Lamps, iron, lighting, box like that.
Yes. You can do anything, any analysis. Summary results will be given like that. Previously I shown summary results. out all the graphs like this. All the graphs will be given. All these graphs will be pasted in your direct paper, so you can work this. Then the maximum power based tracking all will be done. Like that, any system, not only energy storage system,
Is also good.
all energy sources will be there. All renewable energy sources. Wind will be there, marine energy will be there, hybrid energies like PV, wind, battery, hybrid case, and PV, wind fuel cell, photovoltaic, wind battery, generic PV, wind fuel cell, battery, like that. There are different hybrid cases. And some commercial processes, industrial processes also there. Geothermal energy will be there. Solar water heating is there. Biomass combustion is there. Basic generic systems are there. Other
LC only. Directed. LC only directed. Power purchase agreements. Sir, what's the meaning of LC only? Power purchase agreement decide what that is using, sir.
okay.
So what is the meaning of LC only? One.
That is related to losses, sir. Loss calculation on energy. Related to loss. This is the losses. Based on power limits, grid limits, financial parameters. For each and every case, you can simulate it. Some example studies also there, sir, for this. Based on that example studies, you can able to design. If you simulate, a report can be generated. For a particular system, if you simulate, report can be generated. Shall we move on to article discussion, sir?
Yes.
Like this. Various data tables will be there, classes will be there, corresponding graphs. You could create a graph for a particular efficiency of graph. Like that. For every meeting, you can create a graph like this. You can create a graph. And then cash flows will be there, time series. For everything you can get a time series data. And different profiles will be available for different scenarios. Everything you can have statistics will be there. Lifetime hourly data, and then hourly data. Heat maps will be available, and some PDFs corresponding to reports will be generated. For every input, you can get a PDF. Right. This is how the software is working. Next, coming to Next session is article discussion on strategies to enhance solar energy utility in agricultural area of Rajasthan state. In the morning session, we concentrate on Maharashtra state of various renewable energy sources. Now we concentrate on only solar energy based on Rajasthan state. How the solar energy is energy utility is enhanced in agricultural area in Rajasthan state. That is done. Coming to this, in India, the major focus of this particular paper is uh, development strategies to enhance solar energy usage in the agricultural scenarios of Rajasthan state. That is the major case of this particular paper. They are given a survey on various strategies and some solar accelerator programs among rural and agricultural sectors of Rajasthan state of the Indian scenario. In the introduction case, they given the complete literature review corresponding to the solar energy policies, solar energy generation demand, and renewable energy availability or world scenario. After that, Indian scenario for a whole year, upcoming years, like that. They given the complete analysis as a literature survey in the introduction part of the paper. In the last paragraph, they given policies corresponding to various governments because it is for an Indian scenario. New Ministry of New and Renewable Energy (MNRE) is the major authority, and another one is IREDA is another authority which will be the statutory bodies who frame the renewable energy sources like solar based regulations. Those regulations and complete goals will be given for a solar energy generation case. And in current policy and current policy practices, what are the various regulations given by renewable energy certificate and procurement obligations? Based on that, Indian Electricity Act, they are given the complete sections corresponding to each and every action plans for a climatic change and all in this paragraph. And then potential solar energy in Rajasthan state, corresponding to Rajasthan state, what is the complete solar energy in a installed capacity is there, and how many sunny days will be there, according to US Department of Energy.
Rajasthan, I think why we have selected Rajasthan. I think
There are more sunny days.
So 365 days means?
yes, it is 325.
325 days, sunny days only. And that's why for solar, it is a feasible location.
Okay. And also temperature also more, I think.
Even though that sunny day, in a sunny day, the temperature is also very high. Because it is mostly covered with deserts.
Is that
Rajasthan, mostly covered around many deserts will be there. That's why the heat wave will be more. Because of that heat wave, more energy will be generated by solar.
so Jodhpur is known as the Sun City of India.
That's why they given Jodhpur.
Jodhpur. Sun City means this is more solar radiation. That's why
More solar radiation. Most of the time in a day have sun in Jodhpur.
Is it first appearing city?
First appearing and last appearing.
Okay. Jodhpur.
That's why in a day we have a sun but there it is up to 6 hours like that, maximum capacity. Heat wave will be there. That's why yes, sir. And also the radiation also, see, 6 to 7 kilowatt hour per meter square per day. That is very high.
6,000.
6,000 watt hours.
6,000.
That is very high. In the case of Rajasthan, like this. They given all the scenarios here. Solar power potential.
Given the Rajasthan states locations also they have given. Many locations it is possible to generate the solar power.
Which is the distance is also given between different cities. This is a desert. From desert, they have different locations. That's why it is mostly covered with desert. That's why it is a more hottest city. And they are discussing about solar energy in agriculture. They use for crop and grain drying and space and water heating, greenhouse heating, PV remote electricity supply. For remote electricity supply, they use solar energy, and water irrigation pumping also they use solar energy. And some initiatives of solar sector in Rajasthan. There are some of the initiatives in the year of 2010, January 2010. They signed a MOU of Clinton Foundation with Rajasthan government to supply technical support and additional essential aid to launch park utilizing solar harvesting. One park will be available for a solar having an installed capacity of 3,000 to 5,000 megawatt. That is the highest power, 3,000 to 5,000 megawatt in 2010 itself. Likewise, they have some government regulatory rules, and based on that regulatory rules, they given some of the agricultural universities in Rajasthan. Those are Kota, Jodhpur, Udaipur, Bikaner, and then Jaipur. These are the agricultural universities which are available in Rajasthan for agricultural scenarios and academic and scientists working in agriculture. Most of the skilled persons who know agriculture is there in that particular city also. That's why they selected this city. Among farmers, many farmers will have knowledge about agriculture also. These are various results of various demographies in the Rajasthan state itself. Farmers of Banswara village. This is for Banswara village. For various locations, they given complete scenarios, and finally they organized various workshops to farmers, students, scientists familiar about scope of solar energy in agriculture and allied sectors, and some incentive schemes will be proposed by the government of Rajasthan for farmers and rural areas, and some loans will be there 0% with a 0% interest and a minimum interest of 0.5 to 1% only. And then toll-free numbers for farmers where they take information about solar subsidy schemes, and then skill centers will be produced in Gram Panchayati levels, and two or more than government organizations join together for more subsidies up to 90%. Like that, there are promoting solar much more easier way to the farmers. Okay.
Here, participants, this paper is distributed to all the participants. Sir discussed the each and every point. So all of you go through the papers, this paper. Try to submit the morning. I explained how to write article submission. Okay, so the like that you can prepare. Once again, I will show you how to write the paper. Article discussion paper. All of you go through that. So first you have to write the name, your name. All of you try to take the paper, research paper. Attender will distribute the paper. All of you take. Because most of the participants are new to the Atal FTP. So these actually normal. There is a difference between the normal FTPs and Atal FTPs. So Atal FTP, there should be a article discussion and field visits are there. But normal college without industrial visit and article discussions normally faculty development will happen. What is a different format. That's why I'm explaining. So yesterday also we have only few people are submitted. That's why I'm explaining once again. So the first all of you take this same follow the same format. So first write your name, then institute name, your college name, complete college name. After that write area also. Next title. Today's title. This yesterday title. The title of FDP. So title of FDP is the same. Agriculture PV systems and electrical vehicles, pioneering sustainable energy and transportation solutions. This is the same for all the article discussions. Next report one page because the last day we discussed the two articles. So there is a 12 to 1 and 4 to 5. Today also like that. So the mention all of you mention the article session also 12 to 1. If you have any doubt, just note down all the points. After 5 o'clock, all of you try to submit this type of summary. Already experienced people know how to write the article discussion paper. If you have any doubt, please interact with the other faculty members. So I think Sir is very experienced. That's why he is submitted. Take help from Sir also. Just note down. Then next one is so the what next so the today's paper. All of you write the today's paper title. So today's paper that is two articles are discussed. You have to write those titles. If you have any doubt, I will come. No need to worry. At least note down side heading at least. Sir, scroll. You have to give the overview of a topic, today's topic, article number 1. Now you have to include the key components like this. What are the key components? After 5 o'clock, all of you go through the paper and try to identify what are the in the paper. So we may identify the key points, the key components. So the yesterday's paper, sir identified solar panels, agriculture, land, smart systems like that. So like that, you have to identify. All of you try to identify. All of you go through the paper. Need not be same, sir. Identify whatever you feel you have to write. No need to copy from one person to another person. Sure, sir. The topic or if you want to include the benefits, you can include. These papers are related to solar, so you can write benefits of a solar. So the two states, what are the challenges? First paper, second paper, what are the challenges? All of you try to study the challenges and the considerations. First paper and second paper. At least try to note down because you are most of the people are new. That's why I'm explaining. Give some examples also. If possible, in the paper, some examples are available. All of you go through that. On your site, do the examples also. So we have taken two states. Identify the locations. We have taken the one state in the morning session. Afternoon, other state. In the state, what are the locations where solar power is utilized or sources of generation, like that I identified. So this point is important. Societal impact, that is important. That is try to identify what is the social impact. Try to complete, sir. Try to complete. Sir, next. Sir, next. Next. Like this, you can conclude. Conclusion also should be given. Sir, try to open second paper, sir. Second paper. Or not this. You discuss sir, that one. For your convenience, the paper also shown. All of you go through that. Sir, down. Down, sir, down. All of you see the abstract. Then all of you see the introduction also. Complete it. Try to understand the concept. What they have done. Some papers are cited. So the second one, current policy, practice and the regulations in India. All of you go through that. Sir, down. They are the different policies. The central government policies they have explained. Point number 2. Point number 3, solar energy production in the Rajasthan, because this paper is related to Rajasthan. So that's why they reviewed the total potential in the Rajasthan. Second one is completed. Try to complete. Try to note down short forms also. REC, Renewable Energy Certificate, RPO, all of you try to note down. Renewable Procurement Obligation. Next is called down. About Rajasthan state solar energy potential. It has more than 300 to 325 sunny days. All of you know that in the year. So let's scroll down. Okay, all of you see the figure. Note on the points, important points related to this graph or figure. Like this, you can produce the paper, research paper related to your state also. So this is an interesting point. All of you know down applications of a solar energy in agriculture. This is a theme of for this faculty development program. Crop and grain drying, and the space and water heating, greenhouse heating. All of you go through that. All of you try to complete. All of you try to complete. First, try to complete this paper. of you go through the fifth point, initiatives in solar sector in Rajasthan state. All of you note down the points. The participants who are new to the Atal FDP try to take the help from the senior persons. Then move to the results and discussion. All of you move to the results and discussion. All of you move to the results and discussion. And see the 6.1. All of you see the 6.1. Survey with the teaching faculty and scientists. So this is related to our profession. So though it is mentioned agriculture universities, all of you know down. Then move to the 6.2, survey with among the farmers. All of you see the graph. Six graphs are there. Figure number 3. All of you see the paper it mentioned figure number 3. All of you go through figure number 3. Farmers of Udaipur. They are given the graph between solar awareness program among the farmers in the Udaipur village. All of you observe the figure number 3. Then move to figure number 4. All of you move to figure number 4. This is another village. Completed. Next, move to the figure number 5. The survey was done among the farmers of this another village. Then move to figure number 6. And move to figure number 6. All of you try to observe. So 9 points are given in the conclusion. 9 points. All of you see the 9 points in the conclusion. Note down. All of you try to complete the first paper. So title, the strategies to enhance solar utility in agriculture area of Rajasthan state. All of you try to complete. Then all of you see the paper number 1, that is a holistic review of a present and future drivers of a renewable energy mix in Maharashtra state of India. Previously we discussed the Rajasthan state, then we will see the Maharashtra state. So the sir discussed in the morning session. So this paper, total number of papers are 33 pages are there. Okay, don't worry about the page numbers. Okay, the reference, more number of references are there, about 174. 174 references are present in this paper. Identify, all of you see the abstract first. Sir, move to abstract. All of you study the abstract. Identify the points. What are the important points? Mostly these are related to strong energy mix of renewable energy sources. The state of Maharashtra. Completed. All have to try at least to study once. Then move to introduction. All of you move to introduction. Sir. All of you move to introduction. One 74 references are there. All of you see the introduction part. What are the methods? What are the methods used in this paper? That is number 2. Introduction. Now go through the introduction. After that, methods for the survey criteria. When the figure is given, all of you go through the papers. Figure number 1. Framework of a proposed research work. All of you see the figure number 1. Sir, move to next one. Next one. Yes. So these are figure. All of you see the figure. Try to catch the points. All of you try to note down the points. This paper they collected related to the renewable energy development in the various developed and developing countries in the world. Later, they concentrated on Indians' renewable energy sources, and renewable energy status of Maharashtra state is elaborated in this work to prove effectiveness of renewable energy sources in the state. All of you, that is point number 2. All of you see the figure. After that, see the point number 3. This point is mentioned. You completed, try to move the non-conventional energy utilization by various countries. There, the figure number 2 is mentioned. Non-conventional energy systems, the growth of a solar energy in the different countries. Though this paper is related to the Maharashtra state, they collected the data from other countries data also. Figure number 2, all of you see the figure number 2. All of you see the figure number 2. The growth rate of a solar energy in the different countries they have given. And the figure number 3. And the figure number 3, growth rate of a wind energy of a different countries, because it is related to renewable energy. That's why they have given solar as well as wind also. Solar as well as wind also they have given. Which is related to our profession, that is the research activities in renewable energy sources. Many interesting parts are there in the 3.1. You can get many points from 3.1. You can get many points from 3.1. After that, if completed, try to complete the 3.2 policy schemes also. 3.2 policy schemes also. They mention different policy schemes. China also they mentioned. United Kingdom. Dear participants, all of you note down the points. Evening you have to prepare the summary. Most of the participants are new, that's why I am explaining. The move to fourth point, non-conventional energy status and technological developments in India. Figure number 4. All of you go through the figure number 4. The growth of renewable energy resources in India. They have given data over last 10 years. They have given installed capacity versus year. So if you see the graph, figure number 4, year by year, the growth of renewable energy sources is increasing. Next, move to figure number 5. Figure number 5. Here, the up to March 2019, they have given installed capacity of various renewable energy sources. On the x-axis, year is mentioned. On the y-axis, total installed capacity in megawatt they have mentioned. Below graph you can see the technological developments in India. Below figure number 5, they have mentioned technological developments in India. Figure number 7, they have given the Maharashtra state case study, the renewable energy scenario of Maharashtra. A case study is given. All of you open page number 11. All of you open page number 11. Renewable energy scenario in Maharashtra state. A case study is given in this paper. All of you go through that. Note down the important points. They have collected the data of Maharashtra state. All of you see the bullet points also. The 4 bullet points are given. All of you see the 5.1 table. They have prepared the table. The list of solar parks approved under the schemes of Ministry of New and Renewable Energy. Table number 1. There you can see solar park approved capacity and the location. All these things are given in the table number 1. Next, move to page number 15. For easy understanding, they have prepared the table number 3. Extensive progress and the policies of renewable energy in the Maharashtra state. First, they have mentioned the wind energy from 2010 to 2020. Wind energy, all of its summary is given. All of you go through that. After wind energy, they have given solar energy. Move to figure 8. Figure 8. Install capacity of a small hydro power generation. Small hydro power generation. Other potential alternative energy resources. Point number 6. That is the page number 17. All of you move to page number 17. All of you open page number 17 and see the geothermal energy, wave energy, tidal energy. Other than solar and wind, they have considered other renewable energy sources, geothermal, wave energy, tidal energy. All of you try to complete. Dear participants, all of you try to complete. And then move to point number 7, prospective future energy mix of a Maharashtra state. All of you move to 7. Prospective future energy mix of a Maharashtra state. All of you go through that. Next point number 8, exploration of a possible approaches and barriers. Here you can see the many points to write article summary. 8.1, strength and operations are given, central government initiatives, everything is there described, geography, solar mission, job opportunities, policy implications, and then move to table number 5, policies to promote renewable energy resources. So these papers almost they have all the references are given. There is 174 references are given. It's a best paper to understand the renewable energy sources. This focus on the Maharashtra state. All are try to complete. Dear participants, let me summarize the today's sessions. The two sessions are morning session, morning session number 1 and article discussion. So, morning session article discussion is a holistic review of a present and future drivers of a renewable energy mix in the Maharashtra state. So, this article discussion completed. So, the afternoon session, sir discussed the various points related to agri PV systems and the softwares. Sir shown that is Homer software. So these softwares are very useful to do the projects. So you can produce a more number of papers. So the sir shown different data. So related to the electrical vehicles and the PV systems. So you can produce the many papers. So by using the Homer software. So the and then so the 4 to 5, that is the Rajasthan state, the second article discussion, the strategies to enhance solar energy utility in agriculture area of Rajasthan. So the finally, because most of the participants are new to the Atal FDP, so that's why we discussed the how to write article discussion paper. So the, all of you try to submit yesterday discussion article discussion number 1, article discussion number 2. Today's two papers also, because we are running the program from 9 o'clock to 5 o'clock, so you don't have any time. So the after 5 o'clock, all of you today night all of you work all the papers, so try to submit. So the let me remind you, so every day we are sending the feedback form link. So that is the first activity. So the second one is a quiz. Okay, so the yesterday we have completed the based on that we have prepared the questions. So the try to complete that one also. So these two are very important, feedback and the quiz. So the next one is article discussions paper model also. So the I have sent to the mail. So all of you go through that. So the try to work yesterday's two papers and today's two papers. So the with this today's program completed. So now let me invite today's research person Ellen Sastry Garu for felicitation. I request the head of the Department of Vignan Salara Institute of Technology, Dr. Rajni Madam, please join the felicitation to Dr. Ellen Sastry Garu. Sir, please accept the felicitation. Thank you, sir. Thank you so much. for explaining the different aspects of agri systems and solar, and also different softwares. So please try to extend your cooperation in the future also. Thanks, sir.